Tradoon. 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 Tradoon.
I think you should enjoy science as much as you can. And you can't enjoy science alone. You have to share it.
Ontogeny.
Blue is cheap.
Tradoon.
bone wall is so thin, it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir. And well, that's what this thing is like.
Hey, love the stream. Have some cash. Sub to Gene__nature lover. They have given 345 gift subs in the channel.
present to you the top 10 weirdest looking dinosaurs. I want to state the obvious and tell you that I'm going to be butchering the names of these dinosaurs.
Butchering the names of these dinosaurs.
In at number 8, we have the Tradoon. 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 Tradoon.
In 1856, the fossilized teeth of a small dinosaur were discovered in Montana. The species was aptly named Troodon, which means wounding teeth.
Tradoon. Tradoon.
When evolution passed out the stealth gene, Troodons lucked out.
Tradoon. Tradoon.
This drawer contains almost all of the North American identified specimens of Troodon.
Troodon was every inch the predator, with razor-sharp serrated teeth and large, hook-like claws. Troodon probably fed on our ancestors, the early mammals. Troodon may have posed a greater threat to mammals than any other predator on Earth. Troodon was suddenly cut down in its prime.
Tradoon.
Well, hello, everybody. And welcome back to Paleontologizing.
Tradoon.
Oh man, is it good to be back in the saddle again. Apologies for not being on yesterday, but that was something that was outside of my control. Oop. And Dialuta, thank you for the 2
Stumbled over this
months.
stream by accident. Stayed and learned a bunch until then. Thank you.
Thank you, Dialuta. I appreciate you more than you know. Thank you, thank you. For the 2 months of support. Yeah, I couldn't stream yesterday. My internet was out all day, from 9 a.m. until after 8 p.m. Apparently somebody cut a cable or something like that. I'm not sure exactly what happened. The text messages were kind of vague from the internet service provider, but anyway, they've fixed it, and we're back. So welcome back to Paleontologizing, everybody. We're going to have a fun stream today. It's going to be kind of a... we don't have a specific plan for today's stream, so we'll kind of see where this goes, but we're going to have tons of questions. Doing some 3D printing right now.
Danny is connected. Appreciation fee.
And thank you, Golganak. I appreciate those bits. Thank you, Golganak. Yeah. Let me adjust this camera so you can kind of see what's going on. Can anybody guess what's printing right now? It's going to be a tricky one here. Yeah. Anyway. Yeah. I'll tell you about that in a little bit. But anyway, if it's anybody's very first time here, then an extra special welcome to you. Welcome to Paleontologizing. It's great to have you here. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. This is the best way I know of how to do that. You know, reaching a wide audience, talking to people about fossils, answering your questions about the fossil record, about evolution, extinction, the history of life on Earth, and strong emphasis on dinosaurs, because that's what I actually work on. But, Yeah, as a dinosaur paleontologist, I...
The most remarkable animals that have ever existed, and certainly one of the most famous, is a dinosaur.
It's true, Nerdy Noodle.
Back and ready to do it all over again.
Thank you for those 2 months of support, Nerdy Noodle. I really appreciate that. Thank you, thank you. Yeah, putting food on my plate. I appreciate it.
If you're feeling a bit cheated, try blaming the dinosaur.
And thank you, Gene Nature Lover, for those 100 bits. That's a name I don't recognize. Are you new here, Gene? Welcome, welcome. It's great to have you here. Yeah, as a dinosaur paleontologist, I work on dinosaurs. I study dinosaurs. I publish on dinosaurs in the scientific literature. I dig up dinosaurs during the summer. Many of you were here for that this summer when we were live streaming some dinosaur digs. And Rampo86, hello, hello.
This is good start at here, Paleo salute.
I appreciate you, Rampo. Thank you for the 2 months of support. And welcome back. I hope you've enjoyed being part of this community. I really appreciate you keeping me here on the air with your financial support. Thank you very much. Anyway, if any of you weren't here for that, which some of you weren't, if you want to check out our dinosaur digs this summer, which we live streamed.
Tradoon.
Athena Cat, thank you for the 15 months. Really appreciate that, Athena Cat. Thank you. And a Truckhorn.
Here's some objects, gorgeous gargantuans and authentic.
Yeah.
They died out so long ago, their fossil bones remain, so we know just what they're like and can even sculpt them into still, or rather, extinct life.
16 months at tier 2 from a Truckhorn. Holy cow, I really appreciate that. Thank you very much, Truckhorn. That's not quite a Truckhorn, but you get the idea. Truckhorn, thank you. Appreciate you. Yeah.
Let's protect our fossils, because if they're removed, America loses them forever.
It's true, HD and HB. Thank you for... Did you just continue a gift sub you got from Murph? Thank you, HD. I really appreciate that. Thank you very much. You won't have to worry about ads for as long as you stay subscribed now. That is phenomenal, and I appreciate it. And look, we've already got 3 gift subs today. We are... Make that 4.
Let's protect our fossils, because...
Stanky Possum.
America loses them forever.
Thank you for that prime there, Stanky. I appreciate that. What a great username, by the way. Opossums are some of my favorite North American mammals.
Have a moment where it was kind of heartbreaking? I'm destroying, never.
No, glue is cheap.
Senfel, thank you for the 2 months of support. Holy cow, the alerts are coming in thick and fast today. That's brilliant. Yeah. And holy cow, Will62. Thank you for those gift subs. 5 of them. There's now 5 people in chat who won't have to worry about any ads for the next 30 days.
62 really wants ukulele with those 5 gift subs.
Thank you, Will. That is excellent. I really appreciate it. Good stuff. Thank you, Will. Yeah. Thanks for supporting me. You could say, and it would be true, that I am the world's first full-time live streaming paleontologist. Yeah. And I'm really excited because I'm actually going to be talking about this. Not here on stream, but in another venue next week, it looks like. I'm still waiting on official confirmation about this. In fact, let me check and see if... Make sure I didn't miss anything. Not yet. Let's see. Oh, shoot. There's a bunch of message requests here that I missed. But anyway, I am hopefully next week going to be talking about doing paleontological live stream outreach before a group of my colleagues next week. I'm very excited about that, to be giving a talk about this. And gotta confirm that because it's coming up. Shoot. So yeah. Yeah. And anyway. And send to me. No, you're good, Claire. You're good. And sorry, I've been very busy because I've got that. I'm going on a trip pretty soon over the weekend. I'm gonna be... Well, I've got a lot going on right now. Holy cow, is there a lot going on. And my internet was out all day yesterday. So I'm behind right now. I'm very much behind. And Circstar says, hi there to you, Danny Unduza. Hi there to you too, Circstar. Welcome to Paleontologizing. It's good to have you here. Yeah. Will62 says, my pleasure. This is a great stream channel. Wish I'd found it long ago. Thank you. Appreciate that. And holy cow, Murph! Look at this Tinamou bird. Here to herald the arrival of 10 gift subs. Look how happy you've made this bird. Holy cow. Maybe a little too happy. Uh-oh.
Murph is overloading the system with 10 gift subs.
Holy cow, Murph. Thank you, thank you. Do I appreciate you. Murph. Look, 19 out of 150. I decided we might try a weekly sub goal from now on. Yeah. Can kind of better project what it's going to take to run this stream and how much it's going to cost, that kind of thing, and making it weekly like this might make more sense. Thank you for getting us 10 gift subs closer to that, Murph. Thank you very much for your support. You helping to keep this thing going. I appreciate that. Yeah. Tinamou, relative of the Phoenix, says Phalo? Maybe. Yeah. Is there a real bird called a phoenix? I know it's a mythical bird, but I wonder if, yeah. I wonder if there's a real group of birds called phoenixes. Phoenixes? I don't know. Danny Crafts, weekly sub gold chat gonna wreck it. We'll see, Claire Burr. We'll see. Yeah. Yeah. Anywho. Ooh, any guesses as to what might be here on the 3D printer right now? And howdy, Lenina. How you doing? Welcome, welcome. And Will62 says, was Troodon named by a Scot? Because it sounds like it. It's named by an American. We actually just talked about him a few Fridays ago. His name was Joseph Leidy. This is not him. Give me a second here. I was adjusting my camera earlier, and there we go. Joseph Leidy, the father of American paleontology, as he is sometimes called, was the man who named Troodon back in 1856, I believe. Yeah. I don't think he's Scottish, but well, he's American, you know? Yeah. Anyway. Yeah. Yeah. King Joseph I of America. There you go, Andy, yeah. Anyway, what's on the printer right now? Does anybody have any guesses? Maybe if I show you what it's going to look like, you'll have a better idea. I think I have that here. "13 hours, 22 minutes. This is going to be a long file. It's going to take a while to print. But what in the world is that, chat? What in the world is... Mothra? It is... an invertebrate. You are correct about that. Gamera is not an invertebrate phalo. Although Gamera is really neat. You know the rest of the song. And yeah, it's a horseshoe crab. Yes, indeed, which is... Do you know that a horseshoe crab is neither a crab, nor is it a horseshoe? But it's a type of crustacean. Or a type of... No, it's not even a crustacean. What am I saying? It's a type of arthropod called a chelicerate, I believe. Let's look them up on the Tree of Life, and then we'll see if we can find a video on them. Yeah. 1/2 of a fudge Death Star. Not quite, HD. Yeah. There we go. The horseshoe crabs. They are neither crabs nor are they horseshoes. Or nor are they horses either. Yeah. Actually, this is one of those things where it's not any one of those three things. It's not a horse, it's not a shoe, and it's not a crab. Yeah. There you go, Baja Spencer. Nor shoes. Yeah. They are pretty cool critters. They've been around since long before the dinosaurs, and they are still around today. Let's see if we can find a cool video on them. Here we go. Let's see.
Million years old. That means.
Or, let's take a look at this right here. There we go. These are usually pretty good.
They might look like rocks with tails or messed up giant bugs, but horseshoe crabs are super old, super cool, and they deserve your respect. They may have already saved your life. First of all, they aren't crabs. They're members of their very own family of arthropods. Arthropods including insects, arachnids, and crustaceans, known as Limulidae. And there are only 4 species of them in the world. They're more...
Yep, and we just saw that. Well, I can't go back because that's the same tab. But anyway, Limulus is the genus. I think there's only one. Is there only one genus? Let's try and go back anyway. Horseshoe crabs. There we go. It says here there's 13 species. Maybe there's 4 genera? Yeah, this one's not genus Limulus. Nor is this. I think he meant there are 4 genera. Because there's Limulus. That's this one right here. That we are apprinting. But yeah.
More closely related to arachnids like spiders and scorpions than anything else, but really, they're their own deal. They're also mega ancient.
They are. They're older than the dinosaurs. And, as Gimplake says, dinosaurs are neither terrible nor lizards. This is true. This is true. There's a lot of names that we have like that for different critters in science, and the names are very much inaccurate.
In the very beginning of this strange dinosaur's life.
Zenfile, 2 months of support. Thank you, Zen. I appreciate that very, very much. Thank you, thank you. Yeah. Named by colonial Americans. You know, I wonder, Will62. They probably were named by colonial Americans, but let's see where the name horseshoe crab comes from. Let's go to good old Wikipedia. Already donated. Horseshoe crab. Yeah. They are not true crabs or crustaceans. They are chelicerates. Most closely related to arachnids such as spiders, ticks, and scorpions. Yeah. Taxonomy. What's the etymology for the name horseshoe crab, though? I feel like a longer article would have... Yeah. I'm not sure who named them horseshoe crabs. The name horseshoe crab originates from the rounded shape of the head because just like the horseshoe on a horse's foot, the head is round and U-shaped. Yeah. Okay. Well, let's get back to the video here, shall we?
The oldest horseshoe crab fossil we've found is around...
And Neil, if they do have blue blood, yes, they're pretty... I'm sure, Hank is gonna get into this here. This is Hank, right?
450 million years old. That means they have survived virtually unchanged for nearly 500 million years, outliving pretty much anything else. These guys are survivors. So what makes them so tough? Well, part of that is their amazing blood. For one thing, it's blue. Baby blue. Our blood is red because the substance it uses to ferry oxygen around, called hemoglobin, contains iron. But horseshoe crabs use hemocyanin, which is copper-based. So just like iron turns red when it oxidizes, when copper meets oxygen, it turns blue. But that's not even half of what makes horseshoe crab blood.
Like the famously blue Statue of Liberty. You get the idea, you know? It's kind of a greenish blue. But yeah, Rizadego, how are you doing? Welcome back. Good to see you. Yeah. Yeah, and Hank is in remission. He is, Claire Burr. I've been seeing that on Twitter, and I'm really happy for him. That's really good. Yeah. Horseshoe crabs normally swim upside down? Is that right, Murph? I didn't know they swam at all. They seem like benthic critters, kind of scuttling across the bottom. And who knew a horseshoe crab could be an aristocrat? I know, yeah. Blue-blooded critters, truly. It's on the wiki. Wild. Yeah. Huh. And yet it actually blue blood. Yes, indeed. Yeah, instead of hemoglobin, they've got hemocyanin. And do you see the root word? One of the root words in there? Cyan. Like cyan, magenta, and whatever the fancy word for yellow is. I'm just going to say yellow. But yeah, cyan. Blue. Yes, indeed.
When it oxidizes, when copper meets oxygen, it turns blue. But that's not even half of what makes horseshoe crab blood so cool. So seawater is chock full of bacteria, and unlike mammals, horseshoe crabs don't really have an immune system. No infection-fighting white blood cells at all. So if they get a crack in their shell, all that bacteria just gets into their bodies and could wreak all kinds of havoc. What they do have is a glorious chemical found only in their blood cells that binds to and inactivates unwanted bacteria, viruses, and fungi. When the blood cells sense some bad guy invaders, they release a...
Oh, and hang on. Murph found a video of it swimming? Oof, that's weird. Okay, let's take a look.
This is how a horseshoe crab swims.
Whoa!
I see one swimming because they hardly ever do. When they do swim, they swim upside down.
That's wild.
Normally, they just crawl on the bottom, though.
Yeah.
The horseshoe crab has 10 eyes, 10 claws, 7 pairs of legs, and blue blood.
Oh, what a cool see-through canoe. Not only does it rhyme, but what a neat idea for a channel. That's really cool, and I like it a lot. Holy cow. Yeah. They look fairly vulnerable doing that. No wonder they don't do it often. Yeah, a bird could just... Man, imagine a big gull just swooping down and snagging them by the legs.
Their blood is very valuable to the medical industry and is worth $15,000 a quart.
Wow.
Fortunately, they're not endangered or even listed as threatened. The horseshoe crab is a living fossil. They've been around since 200 million years before the dinosaurs.
Yep.
As a horseshoe crab grows, it sheds its exoskeleton regularly.
Wow. That's pretty neat. See-through canoe. What a cool channel. Holy cow. Manatee swimming in the Gulf. These, I think, are mostly drone footage. But there's a canoe right there with a dolphin. Manatees. Drone footage. Look at that. Very, very cool. What a neat channel. That is super, super cool. This guy doesn't even realize. Well, there's a manatee. Well, maybe he does notice. Manatee just swimming there right by him. Super cool. Anyway, neat stuff. Thank you for sharing there, Murph. Very, very cool. Here.
When the blood cells
Here.
all that bacteria just gets into their bodies and could wreak all kinds of havoc. What
Looks
they
small.
do have is
Manatees aren't all
chemical
huge.
found only in
Some are
their
babies.
blood cells that
Yeah.
binds to and inactivates unwanted bacteria, viruses, and fungi. When the blood cells sense some bad guy invaders, they release a protein called coagulogen that forms a gooey barrier around the infecting agents, preventing their spread. That clot of gooiness actually creates a physical barrier, sealing up the wound and preventing further infection. It's an amazing internal defense mechanism. Humans, we have no such ability, so for the past 50 years, we've been stealing it from the horseshoe crabs. Ever since American physician Frederick Bang discovered the weird power.
What a great name. Frederick Bang. Good for him. How many lives did he save with that discovery? Yeah. Very cool.
Been stealing it from the horseshoe crabs. Ever since American physician Frederick Bang discovered the weird power of horseshoe crab blood in the 1960s, these ancient sea creatures have played an essential yet largely unknown role in human medical treatment. If you have ever received any kind of drug or vaccine through injection, it's because these crabs made sure that that injection was bacteria-free. The whole thing starts when horseshoe crabs are collected from the wild, transported to one of only 5 production labs in the world, and then rigged up for a blood drive. Needles are inserted around the heart, and up to 30% of the animal's blood is removed. This stuff is liquid gold. It can go for $15,000 a liter. From there, scientists extract the coagulation.
So, $15,000 a liter. Here, that's like if this cost $30,000, you know, like a 2-liter soda bottle. That's pretty incredible. You know? I don't drink soda myself. But I certainly wouldn't buy a bottle like this for $30,000, you know? Yeah. Oh, and Gimpleg, sorry I missed that, requested Ionosaurus as a dinosaur deep dive 12 minutes ago. Well, we'll get to that. Gimpleg, we will get to that. Ionosaurus, good dinosaur. I think my old boss, Jack Horner, may have named that dinosaur. So we'll talk about it. But yeah, and we think $6 a gallon is a lot for gas. I mean, it's kind of crazy that, like, when you think about everything that goes into petroleum extraction, it costs so much more than that to pump out of the ground, but it's so... and to refine and transport and test and everything else. It's so heavily subsidized by the American government. Gas should be something like $17 a gallon, I think, if it weren't subsidized. It's kind of insane that, like, the whole, like, American auto industry, highway system, everything else, it's like... it's kind of built on a lie. Yeah. Anyway. And Dr. Terra says, can dinosaur deep dives be about formations or transitional times and places? I was thinking about this just a couple hours ago when I was back at the museum in Berkeley. Dr. Terra. We might actually have a bifurcation happening here. We might do... in the future, we might have, instead of, well, here's how it works right now, everybody. Most of you already know, but we have dinosaur deep dives where you can spend a tremendous number of channel points. It's really ridiculous, the inflation on that. But a tremendous number of channel points, it's like 30,000, to have a special deep dive on a particular genus of dinosaur. Like a genus is, you know, like Tyrannosaurus or Velociraptor, or Ionosaurus. That's a genus. Velociraptor mongoliensis is a species. Genus and species. Tyrannosaurus rex is a genus and species. Anyway, I'm beside the point. That's Dinosaur Deep Dive right now. But we've got many long-time viewers, savvy watchers who are like, I want to deep dive on a geological formation or a particular concept in evolutionary biology or something. And so, I thought it might be a good idea to kind of do a spin-off.
Vast supercontinent. Dinosaurs soon occupied every corner of that world.
Semikin, 4 months of support with those primes. Keep them coming. I appreciate that, Sammy. Thank you very, very much. Putting food on my table with those Prime subs. Might not cost you anything. It comes for free with your Amazon Prime account, but I certainly appreciate it. That helps support me. Thank you. What were we saying? Spin-off. This is an idea I was thinking about today. Maybe we have a daily dinosaur, which can be redeemed through channel points. And then we also have deep dives on concepts. And I haven't come up with a catchy title for that yet. But we'll have, give us today our daily dinosaur. And then we have some sort of concept deep dive also. And we'll do one of each per stream. Paleo plunge. Oh, paleo. That's Gimpleg. I like that. Ooh. I kind of like that. Yeah. Paleo plunges. Yeah. Lenina says, I think it'd be fun to have a nonsense channel point redemption, like feed the T-Rex for 50,000 channel points. Yeah. The 100,000 points destruction button. Spend 100,000 points to press it. It destroys your channel points. We could do that. We could do that. I'm gonna write these down. I'm gonna do it right now. I'm gonna write it down right now, I mean. Destroy channel points. Button. Paleo plunge.
Try blaming the dinosaurs.
I like it.
Can inbreeding ever be beneficial for a population? If so, how rare?
Oh, Naderfiend, that's a good question. Thank you for the 100 bits there. Can inbreeding ever be beneficial for a population? So, a lack of genetic diversity. I think probably... No. I think in general, inbreeding is a bad thing. So a lack of genetic diversity, I think, is generally a bad thing. It's hard for me to envision a scenario in which a population of living things would benefit from having a very restricted gene pool. I mean, that's the whole reason why sexual reproduction evolved in the first place. That's why it took off, is that rather than just cloning yourself, you're mixing your genes with those of a mate, and you're creating an amalgam, or a group of different amalga, mixtures, and then, yeah, I think greater genetic diversity is just about always good. So yeah. Yeah, because otherwise you do get genetic issues, Trixmont. Yeah, and we could talk about that too. But here, let's finish up with our horseshoe crabs, and then maybe we'll get into maybe we'll talk a little bit about genetics and about like how genetic mutations are what drive evolution. And thenceforth, why that's important for species survival. Having new mutations, having having a wide gamut of gametes. A wide gamut of, diversity in genes, Yeah. Yeah.
From the blood cells and use it to test solutions that
And
are
Murph,
used
you're
in
right about that,
injectable
yeah.
drugs and vaccines. If the crab blood extract finds
If you're
unwanted
feeling a bit
bacteria,
cheated, try blaming the dinosaurs.
And
The gray squirrels and the color morphs.
gray squirrels and the color morphs. I'm not sure I know what you mean, Risadago. I'm not trying to get you to cheer more bits. You could just type into chat normally, but what? Gray squirrels and the color morphs, what do you mean? Yeah, and Orchestran, we are not just talking about good old horseshoe crabs here. Come on, let's make what the chelicerates. There we go. We're also printing one right now. We are 3D printing a horseshoe crab. Right here. This is what it's going to look like on the print bed. So I guess you're seeing it from this angle. You're seeing it like... It's probably still about there. Let's see. Yeah, there you go. Oh. Isn't technology grand? Yeah, and it will print up like this, and we'll have ourselves a carapace of a horseshoe crab, and then the tail I'll print later. But this is going to be really cool to be able to have up on the wall. Really excited about this. Yeah. And yeah, and shoot, cheetahs are a good example of a critter that they're having a tough time because they are so inbred. They went through a genetic bottleneck to the point where, like, there's not a lot of genetic diversity in cheetahs, and so they're very susceptible to disease. Yeah, it's not good. It's not good. And I'm not making a hat for the field, Atreus. But, yeah. Anyway, back to our horseshoe crabs, which, again, a horseshoe crab is neither a crab, nor is it a horse, nor is it a shoe. We just call them horseshoe crabs.
know that it's bacteria.
There we go.
From the blood cells and use it to test solutions that are used in injectable drugs and vaccines. If the crab blood extract finds unwanted bacteria in the solution, it immobilizes it in a gooey clot. So if your sample doesn't form any clots, you know that it's bacteria-free and safe for human use. This simple procedure called the LAL, or Limulus amoebocyte lysate test.
Yeah, Limulus, again, is the genus name for our horseshoe crab.
It's nearly instantaneous, and no other test works.
Horseshoe crab sun helmet.
The crabs
Oh no.
themselves, most seem to bounce back several days
The
after
tail would be so pokey on the end.
But some folks are concerned that the bloodletting weakens them more than we think. So LAL manufacturers tend to only collect blood once a year to ensure that they're not double dipping on the same crabs, and research is being done to come up with a synthetic alternative so that we can eventually leave them alone. Until then, next time you get a shot, give thanks to all those old horseshoe crabs who made your good health and your sore arm possible. Thanks for watching.
There you go. Very cool. Important critters, horseshoe crabs. Oh, and hang on, Papa Meow Meow. My goodness. Thank you for those 5 gift subs right there. I appreciate that tremendously.
Papa_meow_meow just changed things with those 5 gift subs.
Thank you, Papa Meow Meow. Thank you very, very much. Good stuff. Good stuff. Thanks to you. 5 people in chat won't have to watch any ads for the next 30 days. And look how much closer we are now to our weekly sub goal. We're trying a new weekly sub goal here. But chat has responded to it, not weekly, but quite strongly so far. And I appreciate that very much. So thank you, thank you. Now let's talk about genes and evolution. Yeah, let's talk about stickleback fish. You might not be familiar with these fish, but they are extraordinarily important to the study of evolution. Just this morning, when I was at the museum, I ran into, or rather was in the same room as, a prominent stickleback fish researcher, and one of his doctoral students also, actually. So, let's take a look at this right here. Stickleback fish. Really important critters. You've probably never heard of these little fishes before. They're not the biggest or the strongest or the fastest or the tastiest, if you're this sort of the person who eats fishes. But they are very important, and you'll see why. Maybe they'll be one of your favorite fishes after this.
For tens of thousands of years, much of North America lay buried under ice, up to a mile thick.
Yeah. And Mrs. Aribos, welcome to Paleontologizing. Haven't seen you here before. Is Darwinism? Ism? What do you mean? This the study of evolution. You know, we study how living things change through time. That's what this is all about, you know?
Then,
yeah.
The massive ice sheets.
And they are nasty if they stick you with a spine. They are. Yeah. I guess, I don't know. They're so small, though, that, like, you'd probably have to really manhandle them before you'd get poked, you know? You'd probably end up hurting the fish worse than it hurts you.
Proceeded.
Yeah. Where's their closed captions? Oh, they're on. Good.
In what is now Alaska, ocean-bound streams and rivers emerged, opening up new possibilities for countless species.
Look at that big deer. No sandhill cranes. Not bear.
One of the animals that came...
I know that was a moose. I just like to say that because moose are a kind of deer. They're cervids. Here. Let's go back to our tree of life. Let's go to Cervidae. Let's zoom in here. Yes, the majestic moose. Yeah. Cervidae. So, deer. Muntjac. Eurasian elk, which I guess are we in the US call moose. Canada too, I think they call them moose up there. Red deer, which we would probably call elk. Tufted deer with their little fangs. These are all cervids. Oh, anyway. Here, let's try moose. Alces, right there. Alces americanus is a moose. North American moose. And then Eurasian elk. Who knew that in, well, I guess Europeans knew that in Europe they call moose elk. And elk they call red deer. You know? Yeah. Yeah. And moose is ghostly ghoul. I think that's what they call them in Denmark. That's how they spell it, with the little IKEA O with the slash through it. Well, we have lots of red deer in Scotland. You do, Orchestran. Yeah, absolutely. Yeah. And Naderfian says red deer are found in Europe and white-tailed in North America, I thought. We've got white-tailed deer and we've got mule deer here in the US. Yes. And in some places their ranges overlap. And then you've got European roe deer right there. Anyway, the critters we're supposed to be talking about right now are stickleback fish. Hopefully this will take us to the fish and not some kind of insect that I'm not familiar with. Sometimes... No, it looks like... Yeah, this is going to be a actinopterygian fish. Good. Yeah. There we go. Sticklebacks. these fishes. They're very cool. They're very cool. Mule deer are half horse, half donkey, and half deer. There you go, HD. Yeah, you bet. That's definitely how math works. I'm not a mathematician. I'm a paleontologist, so I'm gonna stamp that approved, and we're gonna continue on. With our video.
Calling was the three-spined stickleback.
Anyway, we'll go back a bit.
Opening up new possibilities.
There's our moose.
Species.
Sandhill crane. Bear. And you made a GIF to prove it? You did, Claire Burr. In fact, let me find that GIF. I believe it is right here. Claire, I still have to share. I've been so busy lately, but I still got to share this on social media at some point. Yeah. Yeah, mule deer. That's half horse, half donkey, and half deer? Yeah, checks out. Checks out. Thank you, Claire, for making that. This is good stuff. Ah! All right, here we go.
Ocean-bound streams and rivers emerge.
Yeah.
Opening up new possibilities for countless species. One of the animals that came calling was the three-spined stickleback.
Yeah.
Common to the Northern Ocean, this little fish spawns in fresh water.
Oh, they are pretty cute.
There are now lots of new spawning grounds to explore.
Oh, yeah.
But as the ice-free land began to rise, streams and the fish in them were cut off from the sea.
What would happen then? Ooh.
Isolate.
Chat, I'm going to quiz you on this. With these little fishes, what would happen when they get isolated in fresh water? Any guesses? Like, I don't expect anybody to guess correctly, but what do you think might happen to these fishes when those streams dry up and they can no longer reach the ocean again? They are stuck in fresh water. What do you think might happen? Take a guess. They get eaten by one and one. They get buried in the mud. They either die or evolve, says Nerdy Noodle. Well, yes. Yes. This is open book Assault Rabbit, but you're running out of time. Inbreeding. Yeah. That's true, Will. Yeah. Yeah. They don't evolve HD, but at least not yet. That takes a long time. Yeah.
Spawns in fresh water.
Okay.
There were now lots.
So, like salmon, they normally live in the ocean, but then they come upstream and they spawn in freshwater. But
of new spawning grounds to explore.
Yeah.
But as the ice-free land began to rise, streams and the fish in them were cut off from the sea.
Yep.
Isolated populations of sticklebacks faced a survival challenge.
Uh-oh.
Could they adapt to full-time life in a freshwater lake? 10,000 years later, they're still there, but they have been transformed.
Ah. This is pretty cool. This is pretty cool.
Stickleback bodies changed in many ways as they adapted to life in post-glacial lakes. They got smaller, their coloring changed, and most strikingly, even their skeletons changed.
Werewolves.
As we begin to learn exactly how stickleback bones evolved,
this is
we're learning
neat.
about a lot more than just fish.
Yeah.
We're learning about how all animal bodies evolved.
And Gamers Tavern Show says, has anyone figured out anything about the whole deal where species keep evolving with selection traits that make crabs? Gamers Tavern Show, we can talk a little bit about that if you want to. What you're describing is that concept of carcinization. But the thing is, it's been a little overstated. It's only true for crustaceans. So crabs are part of a larger group called Crustacea, and different kinds of crustacean have evolved to look like what we would call a crab. But it's not like, you know, mammals and fishes and birds all evolved to look like crabs. It's not like that at all. It's just different kinds of crustaceans. It is still really fascinating, but it's a little bit less dramatic than maybe the idea that you've seen on the internet, you know? Yeah. Convergent evolution on moles this week. Yeah, that sounds good, Gimpla. Go ahead and share that. We're gonna continue watching this though, for right now.
Well, I hope we caught some fish.
Yeah.
This is Bear Paw Lake, one of many lakes created in Alaska by the glacier's retreat 8 to 10,000 years ago.
Yeah, these are little glacial lakes. Very nice. Very cool. So when the glaciers just sat there and melted, they'd kind of push the ground down a little bit, and then, yeah, various scrapes that were made along the ground by these glaciers kind of plowing their way through the landscape. You know, the last remnants of glaciers, shoot, if there are any glacial geologists watching this right now, I apologize, because I am, this is not my strong suit here. But anyway, they're formed by glaciers. I'm not going to try and explain the specifics of why, because I kind of forget. Just know that they're formed by glaciers. That's why they're going in a direction like, or sorry, direction like that. Yeah. Anyway.
The stickleback
There you go. Neither bear nor paw. There you go, A-Rod, yes.
To biologists interested in evolution, such as Mike Bell. Like all freshwater sticklebacks, their ancestors lived in the sea.
Mm-hmm.
In the ocean, there are lots of large predatory fish.
Dr. Bell, I saw him this morning at seminar at the museum. Yeah. Yeah.
And there's no place to hide.
So, sticklebacks evolved body armor, bony plates on their side, and long, sharp spines coming off their pelvis and back.
Mm-hmm. That's why they're called sticklebacks, I think.
Easy for predatory fish to catch, but they're not easy to swallow.
In Bear Paw Lake, however, spines are a liability.
Yeah.
Predators here. But there are hungry dragonfly larvae that grab
the stuff of nightmares. Yowza. So in this kind of environment, you don't want to have spines. Spines are handles for these dragonfly larvae to catch you by and then eat you.
I do call myself an expert in dinosaur studies.
Norby.
6 months already? I
Holy
really
cow.
enjoy your streams. Always learning something new.
I appreciate that, Norby, and I really appreciate your ongoing support. 6 months is a long time, and I appreciate you very much for that. Thanks for keeping me here on the air.
So, pelvic spines actually reduce fitness.
Yeah. By fitness, we mean like the ability to survive in your environment and pass on your genes to the next generation, to have offspring. And so if you've got spines in the ocean, spines are a good thing. In freshwater, they're a bad thing, because that's what the dragonfly larvae catch you with. So yeah. Yeah. Here.
There are no largemouth predators here. But there are hungry dragonfly larvae that grab sticklebacks by their spines. So, pelvic spines actually reduce fitness.
Yep.
And lessen a fish's chances of surviving and reproducing.
So when we use the phrase, and I kind of hate this phrase, survival of the fittest, it's almost kind of like a nonsense phrase, because it's circular reasoning in a sense. Because, well, it's like, well, who are the ones that survive? Well, the ones who are fittest. Who are the fittest? Well, they're the ones who survive and, you know, pass on their genes to the next generation. The fitter you are, the more likely you are to pass on your genes. And who do we determine who's the fittest? Well, they've passed on their genes the most. It's a tautology, you know? And sometimes that's just how things work. That's survival of the fittest, you know? So yeah. Anyway, survival of the adaptable, says Theory and Matt. I mean, In aggregate, yeah. Yeah. Yeah.
In this lake, natural selection has been at work.
If you look at the pelvis of this fish, there's practically nothing there.
In just a few thousand years, these fish underwent a dramatic skeletal change.
Yeah.
Completely losing their pelvic spines.
Huh.
As pelvic spines are homologous to the hind limbs of four-legged vertebrates.
So when we say homologous, we mean that's the same part. So the hind limbs, the hind spines of this fish, or, you know, I guess they would be fins on other fishes, but here they're spines. That's the same as it is on a horse or on you or on a dinosaur.
As pelvic spines are homologous to the hind limbs of four-legged vertebrates.
You got that? Does that concept make sense? Living things, we've got, you know, there's homologies. All living things share some characteristics. In between us and bacteria, we have things in common. The structures of our cells have similarities. But the closer you get to your relatives, your closest relatives, the more and more homologies you share, the more and more features. That's because eventually, if you trace it back far enough, we all come from the same ancestor. Very first life that arose about 3.8 billion years ago. And then life has just been a series of developments on the same theme ever since then. It's not like there's any two creatures that don't share any parts whatsoever. We've all got some parts in common. Even going back to, like, us and viruses who, you know, have RNA. Yeah. All life on Earth, and even some things that are, strictly speaking, not alive, like viruses, all share bits of the same stuff. We all come from the same place. These are variations on a theme. It's pretty cool to think about, you know? Yeah, and that's what this is about, homology.
As pelvic spines are homologous to the hind limbs of four-legged vertebrates, the change we see in sticklebacks is the equivalent of losing legs.
Yeah.
How does such a...
And Birdzidon says you'd think arms, lol? No, the arms are the pectoral fins. So, shoot. I don't think they made it goofier. I think sticklebacks are just kind of weird looking. But, let's see. Fish and tetrapod homology. Well, shoot. Let's look up a... shark anatomy diagram here. There we go. This will work. From the Florida Museum. Thank you, Florida Museum. Yeah. So, pectoral fin right here. That's the, well, basically the arm fins on a shark. Pelvic fin is back here. Pelvic like pelvis, where your legs attach. It's homologous to your legs. Caudal fin. Tail. Here's your tail right there. Of course. Yeah, does that make sense? I hope it does. Yeah. That's homology. It's simple stuff. There's a worksheet that I made at one point for my students back when I was doing like a summer science camp. And it had a bunch of different creature skeletons, different tetrapod skeletons. And I had them color in each of the different parts. Like, let's say color the skull red, you know, the neck, bones, orange, you know, the arms green, etc., etc.
In an unsuspecting world, living creatures from the dawn of time.
They loved it, and they picked it up immediately. It was super cool.
What lives will they destroy? What depths of panic and terror will they create?
Octavius King, thank you.
And their 52 raiders have arrived to wreak some sweet havoc.
Octavius King, welcome to Paleontologizing. How are you doing? It's great to have you here.
I got this poster
How did your stream go?
The American history. Look at these poor malnourished dinosaurs. You can see the fenestra in their skulls.
And what is this, Trappy Jenkins? Here, I'll take a look in a minute. Holy cow, Octavius King. How did your stream go? I hope it was brilliant. Welcome to Paleontologizing. Let me know if you've got any questions. And type a 1 in a chat if you want to see a welcome video real quick. Explaining who I am, how a paleontologist arrived here on Twitch, all that good stuff. Anyway, if any of you are not yet following Octavius King, if you like rats, and rabbits too, then consider checking out their channel and watching them. Good stuff. Thank you, Octavius. I appreciate the raid, as always. And Paxarito, bienvenidos. Paxarito says, hello, fellow paleontologist. Nice commentaries about homologies. Thank you, Paxarito. Muchas gracias. Y otra vez, bienvenidos a Paleontologizing. It's good to have you here. Yeah. But yeah. And we're getting some ones here. Okay. Okay. Yeah. Love the welcome videos, Nivi? Well, let's do one. Yeah. Deepest Blue Dragon says, we've previously set up a dig site for the rats with edible bones. Oh boy, rats eating bones at a paleontological site. I've had rats in my quarries before, but they've been pack rats, who are like really cute little critters with little tufted tails. Yeah. Pack rats are very cute little animals. And sometimes when you're digging in a place like Hell Creek in Montana, you get pack rats and they decide to build a little nest under your, say you're digging up a Triceratops skull. The pack rats will decide to build a little nest underneath the jacket when you leave for the night. And you come back in the morning and pick up the tarps and look under the jacket, and there's a little pack rat just looking up at you with those big black marbles for eyes. And you're like, Scoot, we gotta work here. We've got work to do. But the thing about pack rats is, if anyone on the crew has not been 100% careful about their garbage throughout the day, like say you're eating lunch, and then you've got a bag of dinosaur fruit snacks or something like that. You know what I mean. It's hard to find the bag. But you know those cellophane bags where you tear it and then the corner comes off and the wind just takes it away? If it landed anywhere within a quarter mile of where you're digging, that pack rat will find it, will bring it to the quarry, and will deposit it in a little nest there. So you can tell who has not been careful with their garbage on your crew if you find bits of their garbage that the pack rats have collected.
This
it's
is
good
the
stuff.
horizon, which marks the extinction of the dinosaurs. Below this level, and out in here, there are dinosaur fossils. Above this level, on these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
Vigilanta.
Vigilanta_X and their 9 raiders have stumbled below that level.
Welcome, Vigilanta. It's great to have you here. Welcome to Paleontologizing. Holy cow. And Salem Witch Trials, thank you for the follow. I appreciate you. Welcome, welcome. It's good to have you. Yeah. It's rating hour. Apparently it is, Orchestran. Vigilante, how is your stream? I hope it was real good. Welcome to Paleontologizing. Thank you, sincerely, for joining us. Thank you for bringing your viewers here. Let me know how your stream went. What were you up to? Without further ado, we're going to bring forth a friend of mine. We call him Previously Recorded Danny. Friend to me, friend to all. And he's going to tell you a little bit about who I am, what I'm doing here on Twitch as a paleontologist. How does a paleontologist arrive on Twitch? Well, He's going to tell you a thing or two about that. So I will leave you in his very capable hands for the next couple minutes. Previously recorded, Danny. Go ahead and take it away. Well, thanks, present day Danny. Well, if you happen to be new around here, then welcome to Paleontologizing. You may well be wondering to yourself, well, if this is Twitch, then where are the video games? I'm gonna level with you here. I don't really do much in the way of video games. I'm a paleontologist. My name is Danny Anduza, and dinosaurs are my area of study. But how in the world does a paleontologist end up on Twitch? Well, you're about to find out. When I finished high school, I moved to Montana and immediately started work at Museum of the Rockies, which at the time was an unparalleled powerhouse of paleobiology. That program was built by this guy.
Famed paleontologist Alan Grant.
Well, kind of.
You consulted on that movie.
I did consult on all those movies.
And they said the guy Alan Grant was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
Meet Jack Horner, the real-life Alan Grant. He's one of the most prominent and controversial paleontologists in the country, a dyslexic MacArthur Foundation genius who never finished college and who says he doesn't care why dinosaurs went extinct. To him, the important part is how they lived.
It was at Museum of the Rockies, under the auspices of Jack Horner, that I learned how to be a dinosaur paleontologist. And a huge part of that I learned by working with Jack's final graduate student, a guy by the name of Denver Fowler, who would later go on to become curator of the Badlands Dinosaur Museum. Working with Denver, I did summer after summer of fieldwork in the remote Badlands of Montana. Together, we dug up more dinosaurs than we knew what to do with, at fossil sites numbering in the hundreds. In 2012, I discovered a new species of ceratopsian dinosaur, hopefully soon to be published. The next year, we excavated the world's smallest and youngest Tyrannosaurus rex. Then, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, and we found parts of its armor and plates, and so it should be a new species.
Not bad, right? Well, anyway, much like my fieldwork, my research also focuses on dinosaurs. For example, here's Triarchunkus, the last of the Alvarezsaurs, just published in July of 2020. One of my current projects focuses on Spinosaurids. I can't really talk too much about that until it's a little bit closer to publication, so stay tuned for that. Anyway, let's get back to how I ended up on Twitch. A couple years ago, things in Montana were declining rapidly, so I picked up and moved on to greener pastures. I'm so glad I did. And with that new perspective, I also realized that I have very little patience with the soul-crushing bureaucracy within academia. So for the time being anyway, I decided to take my career in a slightly different direction. I got hired for a job in early childhood education. As a teacher, I get to have a positive impact on kids' lives and help them find a passion for science. Then, when COVID-19 showed up, the school had to close. But that didn't stop the teaching or the learning. We just moved online.
All right, friends. So we're going to be looking at a book in a little bit, but I thought we'd start off with a song. 3, 2, 1. Oh, give me a home
where the hadrosaurs roamed, where triceratops bellowed and grazed, where erosion uncovers bones we seek to discover, for to strike the whole world amazed. Home on the range,
where the deer and the antelope play,
where seldom is heard a discouraging word,
and the skies are not cloudy all day.
It was a pretty easy jump from teaching online to streaming on Twitch. I had my first broadcast in May, and I've been on here ever since. Now, I believe pretty strongly that any good scientist should also be a public servant. In my opinion, talking to everyday people about her science is one of the most important things that a researcher can do. I now have a golden opportunity to reach out directly to people where they are. This is what I'm all about, and now, thanks to Twitch, I get to share it with you. And I'm so happy to be able to do so. It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help by following, or if you could afford it, by subscribing, I would be deeply grateful. So anyway, to my regular viewers, thank you again for sitting through this. To everybody who's new, welcome. I'm genuinely, earnestly glad that you're here. And I hope you stick around. We've got a remarkable little community here, and I'd be delighted if you join us. Anyway, let's go ahead and get back into it. So, present day Danny, back to you. Well, thank you very much, previously recorded Danny.
Try blaming the dinosaurs.
And thank you to Octavius King and Vigilanta for those raids. Really appreciate those. Thank you, thank you. And again, welcome. Young Black Economist, thank you for the 100 bits. Do I appreciate that? Thank you very, very much. Thanks for your support. And Hildebrando, thank you for the follow. Salem Witch Trials, thank you again for your follow. Welcome, everybody. It's great to have you here. Let me know if there's any questions I can answer for you. Right now, we're 3D printing a horseshoe crab. Man, it's gonna all told, this model's gonna take about 15 hours to print, but it's gonna be really nice, and I'm really excited about it. And we're talking about evolution right now, as we often do. We're talking about the evolution of certain structures, like in stickleback fishes. We're talking about the loss of those spines and what it can tell us about changing environments and how creatures adapt to new circumstances. So, here we go.
In this lake, natural selection has been at work.
Yeah.
The pelvis of this fish, there's practically nothing there.
Ah.
In just
no pelvic
a few thousand
spine.
years, these fish underwent a dramatic skeletal change,
Pretty cool.
completely losing their pelvic spines.
That's nuts. Let's see that again. From this, in just a few thousand years, to this. Holy cow. That is pretty dramatic. Before, after. Before, after. That's pretty cool. That's pretty cool. Evolution speedrun, says Hexif Kirsten. Yeah. Yeah. That's why sticklebacks are such a wonderful, what we call laboratory organism. Because you can use them to study different biological concepts. Like in here, we can use them to study rapid evolution. It's pretty cool. And Athen of Athens, how are you doing? Welcome, welcome to Paleontologizing. Good to have you here. Thanks for joining us.
A few thousand years, these fish underwent a dramatic
Look at that. From this to that. Crazy.
Spines.
Yeah.
As pelvic spines are homologous to the hind limbs of four-legged vertebrates.
So like we were talking about earlier, these are the pectoral fins right there, and then these are the pelvic fins.
The change we see in sticklebacks is the equivalent of losing legs.
Yeah, that's
How
nuts.
does such a dramatic change in form occur?
Huh.
For Stanford molecular geneticist David Kingsley, the transformation of the stickleback pelvis opened a door on an evolutionary puzzle.
Wow, there's quite the overrepresentation of Bay Area scientists here. Stanford, right there, Dr. Kingsley. We had Dr. Bell earlier from Berkeley. Holy cow, it seems like the San Francisco Bay Area, it really is the place to be. They are flocking. They're flocking to the San Francisco Bay Area, Freelancer. Yeah. Anyway, let's continue.
What happened at the genetic level at these early stages where the body plan is first being laid out that makes the difference that we now see?
The physical forms of all animals are products of development. That process in which a fertilized egg grows and is shaped into an adult. Changes in form, therefore, arise from changes in development. And since genes control development, changes in form are ultimately due to changes in genes.
Yeah.
David, these two fish...
My HD says some interviewer had a BART pass to use up. There you go. Although BART doesn't go to Stanford, does it? I don't think it does. I took BART to Berkeley this morning. Bay Area Rapid Transit. One of my, my beloved Bay Area public transit. But I don't think it goes to Stanford. It goes to Berkeley. It literally drops you. Downtown Berkeley Station is 1 block from campus, which is pretty awesome. But yeah.
Look different. But they have thousands of genes. How do you pinpoint which genes make the difference?
We started like any geneticist starts. You got to have two things that are different. You got to cross them.
Geneticists use crosses to map the location of genes that make the difference. Ocean and freshwater varieties of stickleback can be crossed by collecting sperm-filled testes from males and eggs from females and mixing them together. In a matter of days, the beating hearts of stickleback embryos are visible through a microscope. When mature, this first generation is bred again. Each cross reshuffles the genetic material and traits that are passed on from one generation to the next. Traveling with the genes are stretches of DNA geneticists use as markers.
And that gives you the chance then to try to figure out which of the pieces at the genetic level go together with the traits that you see visually at the whole organism level.
That's done using the DNA markers to link the trait, in this case the presence or absence of a pelvic spine, to general locations on specific chromosomes. This hunt eventually pointed a finger at a well-known and powerful developmental control gene called PIDX1. So, naturally, they compared the PIDX1 protein coding sequence in fish with and without pelvises.
What'd you find?
Well, we actually didn't find anything at all. At the coding region of the PIDX1 gene, the actual part that makes the protein, there isn't any difference between marine and freshwater fish.
Well, that's fairly puzzling. I mean, we for years were used to the idea that if there's an evolutionary change, that there'd be a change in the protein made by a gene. So you see no differences in the sequence of the PIDX protein between the two fish. I mean, isn't that a paradox? Isn't that a surprise?
Well, it's still possible that there's something about the expression or the regulation of the gene that's changed. So the structure is fine, but maybe the timing or the place it's normally expressed is different.
Interesting.
Find out. Kingsley's team...
I do kind of wonder if this is what you would call, like... if this would have anything to do with, like, epigenetic changes? Because it isn't just... to say that all of the changes that occur between generations are...
absolute prerequisite to the evolution of large mammals, and to our own existence, for that matter.
Athen of Athens, thank you for the follow. Welcome. To say that all of the changes that occur between different generations are just genetic changes is not 100% true. Because genes are only part of the story. It's also how those genes are expressed, you know? Imagine that, like, you've got, like, a Lego model, and you write out some instructions, you know, for how to build it, and then you give it to a friend, but then somehow you screw it up in the photocopying when you make a copy for them, and so it's just like a little bit different somehow, you know? Maybe the last page is missing or something like that, or something gets lost in the shuffle, you know? That would be like the genetic code changing. But if you copy it exactly correctly and then give it to your friend in order for them to make this Lego model, maybe they interpret it in a slightly different way. It's not like a change in the genetic code. The instructions are still the same. But the way that they're expressed, the way that those instructions are utilized, changes a little bit. And this is also probably a really important mechanism in evolution. This is something that I'm sure there are people who are studying these things actively. This is outside of my field, and so you should probably talk to, like, Balint from Science Streams about this, about gene expression. And, yeah, I'm sure Balint would be more than happy to talk to you about it when he's on. Maybe we can raid him later if he's on. We'll see. But, yeah, genes are not the whole story. Not every change in evolution occurs because of a change in the genetic code. That's a little bit too simplistic, as I understand it. And again, this is coming from somebody who studies fossils, and so I'm not a geneticist. This is outside of my wheelhouse. But all of these things are interconnected. All of these things, you know, have got connections to one another. All of science is kind of holistic in that sense. You know? We're studying the natural world, and the natural world has many, many different aspects to it. It can be studied from many, many different angles. Many different kinds of scientists can study it. So that's why we on Paleontologizing are watching a video of some guy with, you know, latex gloves. It could be nitrile, but they're probably latex. Looking through a microscope. Stuff in tubes, you know? Yeah. And Gamer's Tavern Show, that was the video that I almost clicked instead of this one. The one about elephants. Not evolving tusks anymore. Yes. Or evolving to no longer have tusks. Maybe we'll watch that one next, because that one's also really, really good. Gamer's Tavern, yeah. Yeah.
Embryos with a chemical dye that turns blue any tissue where the PIDX1...
And Athen of Athens says, how does one become a paleontologist? Ooh, boy. I can talk about that a bit when we're done with this video. Remind me, and I'll talk about that with you. But volunteering at a museum is your best first step, if you can do that. Yeah.
Messenger RNA is produced.
Yeah, elephants can super interesting lineage, yeah.
You see the PIDX1 gene is expressed in multiple places. It turns on in the head region, in the lips, inside it would be on in the pituitary. But it also turns on along the side of the body, this very strong blue patch here.
In that tissue, it's telling cells to
very
start
funny
growing
freelancer.
a full pelvis and spines. And what about in fish that aren't going to make a pelvis?
Right. Key moment in the lab was the same experiment in the lake fish. The head region, you still see blue on the lips. You still see blue inside the head. You don't see that little key blue spot along the side or on...
And Flying Spaghetti Monster, very funny. I occasionally wear gloves in the field if I'm doing overburden. If I'm swinging a pick or using a shovel or throwing a bunch of big rocks, I'll put on gloves. But otherwise, gloves are often a bad idea. I know you know this. I'm just... Yeah. Yeah. Anyway.
The ventral surface of the fish.
So the structure of the protein is the same between the two populations, and the expression of the gene is the same between the two populations, except for just in the pelvis.
How can the expression of a gene change in one part of the body, but not another?
Huh.
This is possible because the coding regions of most genes that control development are surrounded by a number of regulatory switches, each of which controls gene expression in a different tissue. Like all DNA, the sequences of switches can acquire mutations.
Chuck! Chuck! It's Marvin! Your cousin, Marvin Berry! You know that new sound you looking for? Well, listen to this!
CosmoQuest, thank you for the raid. Welcome to Paleontologizing. How are you doing? It's good to have you here. How did your stream go? I hope it was real good. What kind of nonsense did you get up to? Let me know, CosmoQuest. I want to hear about it. Welcome to the channel. I didn't mean nonsense in a disparaging way. I'm just trying to be informal. I'm sure whatever you were doing was very informative and really cool and interesting. Because you were doing some science and technology. Beautiful. Stream went great. Lots of good science to chat about today. Excellent.
Gigantic
Appreciate it.
attacking our boy!
Thank you for being here. Tommy Boy 212, thank you for the follow. Welcome. Well, also in a non-disparaging way, the kind of nonsense we get up to here on this channel is fossil science. Right now we're talking about evolution, which we can observe in the fossil record, or today in the laboratory. We can watch living things change through time. It takes some extra work to do it, well, through fossils or in the laboratory. Each have their own strengths and weaknesses, pros and cons. But with stickleback fish, you can basically, like, kind of watch them evolve in real time. It's super cool. That's what we're talking about right now. We're also 3D printing a horseshoe crab. It continues to continue. Very excited about that. But let's get back to our video here, shall we? Let's go back just a titch. Here we go.
Body, but not another. This is possible because the coding regions of most genes that control development are surrounded by a number of regulatory switches.
A little bit of this goes over my head.
Controls gene expression in a different tissue.
Because,
like all DNA, the sequences of switches.
Again, I'm not a gene scientist, not a geneticist.
Kingsley had a hunch that the switch regulating PITX1 expression in the pelvic tissue of freshwater sticklebacks was broken. But to find out, he had to first find that switch.
Ooh, this is the thing in science. A hunch is only as good as a hunch. For it to be scientific, you gotta test it. You gotta test it. That's what science is all about. Anybody can say anything in this world. But if you want it to be scientific, you gotta test it. That's what this is about.
Geneticists find switches by tracking the expression of a reporter protein that glows green where a switch is active.
Whoa, what? Literally glows green?
Cutting the DNA around the PITX1 coding sequence into many different fragments, they attach the green reporter gene to each of them.
Huh.
Then, they injected those fragments into stickleback eggs.
We wait a week or two, and then we ask, are our sticklebacks glowing in the pelvis?
After 5 years of testing different fragments, they had fish with glowing pelvic tissue.
Holy cow, is that cool? This is how science works, folks. And this is a long time coming. 5 years of experience before they got it to work. But they got it to work. The proof is in the pudding. And there you go. There's the pudding, glowing green right there. Not literal pudding, figurative pudding. You know what I mean. Very cool. Very cool. Yeah. And Plouf says, meanwhile, in theoretical physics, yeah, someone in 60 years will test, no worries. Yeah, you know, there's an argument that, like, modern physics, especially, like, quantum physics and string theory especially, has gotten to the point where it's no longer testable and is more in the realm of philosophy more than it is science, which is kind of funny, because if you talk to physicists, sometimes they're like, oh yes, well, physics is truly the queen of the science. It's the only true science is physics. It's like, well, shoot. There's an argument to be made that several aspects of your science have kind of strayed outside of the bound of science. They're more philosophy than they are science now. I don't know. I'm not a physicist. I don't have a horse in that fight. But, yeah. I do dislike it when scientists in one field of science disparage another field of science and go, well, you know, our science is the only true science. As physicists are notorious for doing. If you're collecting systematic observations about the natural world and then you're testing them under controlled conditions, you're peer reviewing your research, publishing it, you're a scientist. That's how science works. So yeah. Yeah. Anyway. The XKCD about the purity of science. I don't know if I remember that one, Gamers Tavern Show. Let's look that up. Anyway, welcome Plouf, it's great to have you here. Welcome to Paleontologizing. It's great to have you here. I hope you stick around. Yeah. Oh boy, what is this? Sociologists. A psychologist says sociology is just applied psychology. Biologists say psychology is just applied biology. Chemists say biology is just applied chemistry. Physicists say which is just applied physics. It's nice to be on top. And mathematician says, oh hey, I didn't see you guys all the way over there. Which, is mathematics really... Is it a science? You can debate in the chat. Again, I don't have a horse in that fight. I'm gonna sit over here with my fossils and not get involved with that debate. Because what good would that do me? But yeah. And harasses Professor Dr. Danny. Don't call me that. Call me Danny or hey you. Just don't call me late for dinner. Can you prove about physicists' arrogance? It's personal experience, you know. Anecdotal evidence, which is itself an oxymoron. But yeah. I'm gonna keep my fighting horse out of this one. There you go, Dr. Irrefutable. Yeah. Smay says, people ask, are birds real? But is math real? Oh boy. If you want, as a special treat, we can torture ourselves toward the end of the stream with that video that's been making the rounds about that woman on Tink Tonk who says that dinosaurs are not real, but giant, like Jack and the Beanstalk was a true story, that human giants are real. Maybe we'll get to that at the end of the broadcast if everybody's good. We'll see. Yeah. Anyway. Let's get back to our video here about sticklebacks.
They'd found the stretch of DNA that contained the PIT-X1 switch.
Very cool. Very, very cool.
Sequencing that region revealed a dramatic mutation.
Fish that have lost their pelvis have deleted the pelvic switch. It's
there we go. Bloop.
But because this mutation only crippled one
Highlight.
specific switch,
Delete.
the PIT-X1 gene remained fully functional in the rest of the body.
Do that, you can have a huge effect on the development of that structure, but the fish is fine. Actually, the fish is better than fine. When that deletion occurred, it conferred an advantage on the fish, and that mutation spread throughout the entire population.
So the obliteration of that switch actually makes these fish better adapted to the new environment they're in.
That's right.
Than their ancestors.
With the switch identified, he was ready for a final test.
If
Very
you've
cool.
got the right switch, you ought to be able to put it back and reverse the evolutionary trait.
Yeah.
So, they joined the working switch to the PIT-X1 coding region and injected the combination into eggs from a freshwater stickleback that would normally never form pelvic spines.
And
that was a good day in lab.
Oh, hang on. Let's see that again. Because I wasn't exactly following right there. I'm guessing there's some people in the audience who weren't necessarily following 100% right there. What happened here?
So, they joined the working switch to the PIT-X1 coding region and injected the combination into eggs from a freshwater stickleback that would normally never form pelvic spines.
So they're going to try and take genes from a fish that would develop spines and put it into a non-spiny fish. Let's see if it develops spines.
And
that was a good day in lab. It works. There's a fish now swimming around the tank. Hasn't formed a pelvis for, maybe thousands of years. It does, if you put back in the key sequence.
Holy cow. That's super neat.
Team had found the broken switch that caused fish from one lake to be without spines.
Huh.
But that isn't the only place one can find spineless sticklebacks. When he looked at fish from other lakes, he found something remarkable.
If you look at a fish that's lost its pelvis in Scotland or Iceland, Alaska, or British Columbia, the same switch has been thrown away.
Convergent evolution. Really interesting. Fish in disparate populations around the globe that underwent similar changes in environmental conditions evolved the same feature. That's convergence right there, baby. That's pretty cool.
Over and over and over again whenever the fish have evolved the loss of a pelvis.
Given the same selective conditions, evolution can and does repeat itself.
Very
right
cool.
down to the level of the same gene and genetic switch. And amazingly,
This is it. This
well,
is
well,
the
Lordy.
horizon, which marks the extinction of the dinosaurs. Below this level, and out in here, there are dinosaur fossils. Above this level, on these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
Lordy, how are you doing? Welcome.
Traders have stumbled below that level. Let's talk dinosaurs.
Let's talk dinosaurs, Lordy, and stickleback fishes right now, as we're talking about evolution of different traits and how those traits are passed on, that kind of thing, how they're expressed. Lordy, how are you doing? Welcome back to Paleontologizing. I hope you had a wonderful stream. Tell me what you're up to. Doing more sewing today, perhaps? Makers and crafting? How did it go, Lordy? Tell me all about it. And welcome back to Paleontologizing. If any of you are not yet following Lordy, you're missing out. Her streams are a lot more chill than mine are. And she does sewing live on stream. So if you're into sewing, or if you're the sort of person who wears clothing, well, you can watch her make clothing live on stream. Lordy's one of my very favorite people on this planet Earth, and a member of my stream team, along with Ios. Go follow both of them, honestly. Ios does video games. Lordy does sewing. I do fossils and other assorted nonsense. So yeah, we make a pretty eclectic team, I would say. And but yeah. And you try to wear clothes, but not always successful, Baja Spencer. Maybe Lordy can give you some pointers on that. Yeah. Anyway. Yeah. Lordy, hope you had a great stream. Thank you again for the raid. Let's continue with this video, shall we? Boom. There we go.
it appears that the same adaptation has also occurred in the much deeper past.
Pretty cool. Yeah! Oh boy! I've done fieldwork here. These are the diatomaceous earth deposits, Pliocene in age, I think. Pliocene or Miocene, near Fernley, Nevada. I have dug here with Tanner Frank from UC Berkeley. And you even see some footage of that sometimes in the cold open videos. Or the welcome videos. You know, Cenozoic fishes. Here. Look at that desolate Nevada landscape.
Years ago, this Nevada desert was a lake full of sticklebacks. Their fossil remains have long fascinated Mike Bell.
Very cool. And thank you, Flying Spaghetti Monster.
Every year, many stickleback would die, and their bodies would drift to the bottom and be covered with sediment. The flesh would rot off the bones, and very often would leave a beautiful intact skeleton.
Early on, Bell realized that there were two distinct types of sticklebacks preserved here.
Some of the fish had a really big pelvic bone behind it.
Yeah, look at that.
And other fish didn't have that bone, but a little tiny pelvic bone.
One might expect one or the other to be favored by natural selection. So why were they both here?
Interesting. And they are they're beautiful fossils. I found a bunch of them. I was there in 2019 with Tanner and Jamin and Kat and a number of other paleontologists. And yeah, it was a lot of fun. It was just like a weekend trip over Labor Day weekend 2019. But yeah, gorgeous fossils.
This quarry has 1,000
Hey, Echidna, how you doing?
in every foot of rock. 1,000 years of annual deposits.
Pretty
A record
cool.
of change like that is an evolutionary biologist's dream. To move from one end to the other is to move through time. By painstakingly checking fossil pelvis size over a 20,000-year period, Bell made a surprising discovery.
It's got a fish, pretty nice fish.
Fish with a full pelvis had arrived suddenly, perhaps when some geological event briefly opened the lake to the sea.
Huh.
Yet,
interesting.
Within a few thousand years, almost all sticklebacks here lacked pelvic spines.
Interesting. So this is like, you might be able to track whether this lake is open to the sea or not based on who is favored, those with reduced pelvis or full pelvis. Because in freshwater, having a full pelvis, not good. Freshwater predators can more easily catch you by grabbing those. But if you've got to mostly worry about oceanic predators coming in from the sea, when this area is open to the sea, you want that full pelvis. This is so cool. This is one of the things that, without fossils, we would not be able to track these kinds of changes. Because we're living today in the present, and we can only deal with creatures from the present, or from very near in time, where like creatures that were collected just maybe up to maybe 200 years ago, something like that. But with the fossil record, we can go back thousands, hundreds of thousands, millions, even billions of years, and see what creatures were doing back then, what secrets their bodies held. It's really cool. This is what paleontology is all about.
And in Alaska, we're seeing exactly the same phenomenon taking place, but it's 10 million years later.
Very cool.
The same animal, at two distant moments in time, undergoing the same transformation. In both cases pretty quickly, and in all likelihood, via the same evolving switch.
Very cool.
This is a really exciting time to be a biologist. Only 10 years ago, we couldn't get at the DNA of
Probably 20 years ago now.
in a detailed way. And now you can combine that kind of information with natural history. We can link up genetics to development, development to phenotypes, phenotypes to environments. We can look at change through time in the fossil record. We can put together the whole package.
Very cool.
As biologists do just that, they're finding that the most common mechanism driving the seemingly endless diversity of animal bodies is mutations in the switches that regulate developmental control genes.
Pretty awesome. Pretty awesome. Yeah. Very, very cool. Here's a link to that video there. And we had, in chat, mentioned elephants. And that's another video. Right here. The genetics of tusklessness in elephants. This is actually from the same producers here. Let's check this out. Talking more about the evolution of different advantageous traits. You would think that having tusks would be a good thing as an elephant. Helps you defend yourself, find food, stuff like that. But conditions can change. Sometimes tusks can be a disadvantage to have. I love elephants too, Calamity, now. They're very, very cool animals. Take a look.
Normally, more than 90% of female African elephants have tusks. But in places that have a history of poaching and trophy hunting, like in Gorongosa National Park, tuskless females are surprisingly common.
Huh.
Despite this tragedy, we have a unique opportunity to show how humans are impacting the evolution of animals in their natural habitat.
That's pretty
In a
cool.
situation where individuals are being actively hunted for their tusks, not having those tusks puts you at an advantage, right?
Yeah.
And if you're less likely to be killed, then you're more likely to pass those tuskless genes on to the next generation.
Did you get that? This, like, that's a beautiful description of natural selection. In this case, it's artificial selection because it's humans doing this. But it's the same thing, you know? Whatever the factor is that's causing the selection, it's the same concept there. You get that? I'm going to rewind that and play that one more time because this is really important. It was a beautiful distillation of that, you know?
They're being actively hunted.
Here we go.
To show how humans are impacting the evolution of animals in their natural habitat.
Sculpin says, we call it animal husbandry. Yeah, when it's artificial selection, selective breeding like that. But when it happens in the wild, we call it natural selection. Yeah.
A
Yeah.
situation where individuals are being actively hunted for their tusks. Not having those tusks puts you at an advantage.
Yep.
Right? And if you're less likely to be killed, then you're more likely to pass those tuskless genes on to the next generation.
Oh, yeah.
This is the basic process of natural selection.
Yep.
To better understand how the tuskless trait is evolving under selection from poaching, we want to find out which genes are responsible for tusk development. But elephants have thousands of genes, so how do we find the right ones?
Oh boy.
Tusks themselves are modified teeth.
Yeah, they're
Because
canines?
all mammals generally share the same genetic program for building teeth, we looked at the genes involved in tooth development for a species we know a lot about.
I was going to pause it and ask, what is that species? But I paused too late. It's going to be these, what we call Homo sapiens.
Humans. Within humans, there are about 3.
It's the common dingus, says Spotak. There you go.
Spared no expense.
Yeah.
An anonymous user gifted a tier 1 sub to Confused Echidna.
Thank you, Anonymous. That, you've got very good aim there. Confused Echidna is a wonderful recipient, and I appreciate you picking them, Anonymous Gifter. Thank you, thank you. Yeah.
300 genes that are generally involved in tooth development. I mean, it's still a lot of genes, but it also kind of narrows the scope if you're considering an entire genome. The elephant counterpart to at least some of these genes are most likely also involved in tusk development. So far,
Ooh.
we've collected blood samples.
Whoa, 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 hang on. Shooting elephants from a helicopter. That better be a tranquilizer rifle. That better be a dart being fired from that barrel there.
So far, we've collected blood samples from several.
Okay, that sounded like a and not a so good. Good, that sounded like a dart.
Elephants and Gorongosa to isolate their DNA. Once we get those samples back into the lab, we'll sequence them and look for differences in the DNA sequences of females with tusks and females without tusks.
Huh.
Because we're looking within the same population.
And I'm guessing here, so like tranquilizing an elephant while she's running with her herd here is like, it's got to be a traumatic experience. I'm guessing that these researchers, I'd be willing to probably put a little bit of money on this. These researchers collecting this data, they're just kind of glommed on to this crew. I bet you this was an elephant that probably had to be introduced to the nature preserve here. Probably needed a checkup. They needed to run blood tests and stuff anyway for the well-being of the elephant. I don't think they tranquilized this elephant specifically for this scientific study about tusklessness and elephant genes. Because shoot, it's very rare that a scientist doing basic scientific research would ever have that kind of funding. I'm guessing that they needed to take a blood sample from this elephant anyway, for whatever reason. But yeah, they'll also do that if one is injured. There you go, Lenina. Maybe that was it too. I don't know. Yeah.
Blood samples from several elephants in Gorongosa to isolate their DNA. Once we get those samples back into the
There's
lab,
your link, Babzilla.
we'll sequence
Welcome.
them and look for differences in the DNA sequences of females with tusks and females without tusks.
Yeah.
Because we're looking within the same population, most of the genome should be relatively similar, except at those regions of the genome that are specifically involved in the trait differences that we're interested in. So if we pick up any differences in this elephant population that happen to coincide with genes that we know are involved in tooth development, that is kind of a smoking gun.
Nice.
Once we find them, we can ask, how is the prevalence of these DNA differences?
I think it's
or
just an add-on. I
alleles
think you're right, Flying Spaghetti, yeah.
in elephant populations that are experiencing poaching? Evolution is, a process that has been happening for a very long time, but it's also something that is happening now, right now, in and around us. And, we are a major driver of that process.
We as human beings, yes. Yeah.
Before this project, I had never been to Africa. And obviously, for me, there was, it's a very special thing, right, to go back to the motherland. And this project,
I mean, honestly, it should be a special thing for any human being. We all came from Africa. If you go back far enough, human beings first evolved on the African continent. We're all children of Africa. You go back far enough. Far enough. It doesn't have to be very far at all. We're just talking about the origin of humanity. Just a couple million years ago, So, yeah.
Honestly say has been the most astounding experience of my life in a lot of ways. Working with elephants is something special. Yeah, just like the grand scale of the creature. We tranquilized this female, and as we were collecting data, Dominique, one of the scientists, she identified the individual, and this female was like 65 years old.
Wow.
I mean, she's older than my mother. 9 out of 10 of the individuals in her species died during a 15-year period. And she survived that event, became the matriarch of a herd, leading a family, had children, had grandchildren, and there she is, right? In all her thousands of pounds of glory, It's hard to explain, right? To be able to interact with an animal that has experienced so much. That to me is really special.
Pretty cool. Pretty cool. Again, here is that link. If you want to watch that for yourself. But I guess that's the point I want to make from these videos, is that science is integrative. What does that mean? It means that we integrate different findings from different fields, different avenues of study. We integrate them together to learn about the natural world. Just like to learn about stickleback fishes. You can study those fishes in the laboratory, you can study their genes, and you can go back in time, like literally go back in time by looking at fossils of their ancestors from 10 million years ago. So you've got modern biology, you've got genetics, you've got paleontology interweaving like that. A beautiful synthesis of different scientific fields, because at the end of the day, as scientists, we're all trying to learn about the same stuff. We're trying to learn how the world works, how these natural processes occur. And it's such a privilege to be involved with this in some way. I gotta tell you, it's a cool feeling being a scientist and knowing that you're part of this huge international project that we call science. If any of you in chat are thinking about, you know, pursuing a career in science, I would encourage you to do so. You're not going to get rich doing that, but you'll be much more wealthy in something more important. The knowledge that you're making the world a better place, you're adding to the sum total of human knowledge. You're adding a handprint on this, you know, global cave wall that is scientific inquiry. You're saying, hey, I was here. I contributed to this. Today, as scientists, we're standing on the shoulders of giants, people who made these discoveries initially a long time ago, and we're building upon that. To be one of those giants on whom later scientists stand. It's a weird way to put that. It's pretty cool, you know? It's interesting to think about what people will think about us in the future, you know? Anyway. Yeah. Clockwork Griffin says, I already did, and I love it. There you go, Clockwork Griffin. Welcome back. It's good to see you here. Yeah. So giants did exist. Oh boy, HD. We'll get to that later. Remind me, we'll get to that. Yeah. And Confused Echidna says, Danny, what do you say to someone who says, I'm not smart enough to study science and become a scientist? I say this with all of the appropriate tenderness, gentleness, and love required for such a statement, but not every scientist is very smart. I know some pretty dumb scientists, to be honest. And sometimes they still make really important contributions to scientific fields. You don't have to be some sort of super genius. Shoot, I was just reading about well, shoot, for crying out loud. I was just reading about this guy. Kind of an obscure scientist from an obscure field of science. Maybe, I doubt anybody's ever heard of him before. But his name is Albert Einstein. And he made some contributions to science that some people would say are kind of significant. And yeah. Jody Fisher says he couldn't balance a checkbook to save his life. Yeah, and he didn't know how to do his own laundry. When he was young, when he was a child, people thought he was stupid. Like, everyone called him dense. The thing is, if you find what you're passionate about, if you find the thing that just clicks with your particular brain, if you find that field of inquiry that your mind works with, you can achieve remarkable things. You know, today, the word Einstein is synonymous with genius. But this is a man who did not know how to wash his underwear. So I don't know if that's any kind of reassurance, Echidna. you know, to anybody who says, oh, I'm not smart enough to be a scientist. That's the thing. If you are passionate about finding out the way things work, about testing ideas, if you are driven to discover new things in a systematic way, you could be a scientist. Whether you can get a job in the sciences is another matter. Einstein himself, I was reading, it took him like a decade to even get the most basic job in academia. He just kept getting rejected again and again and again. Before I think he applied for to be a high school teacher because they wouldn't hire him at the university. And there were 3 other candidates who got the job before he didn't even get a job as a high school teacher. So yeah. You can have a mind for science and not have people consider you particularly intelligent. You know? Yeah. Anyway. Yeah. And yeah, so Sculpin, after Einstein got his first job in academia as like some sort of adjunct professor or something like that at the University of Berlin, I want to say, the job paid so poorly that he could not possibly have survived with that job alone. So he kept his job at the patent office at the time while he was a professor at the university. Because the pay was so poor at the university, he never could have made ends meet just with that. So yeah, a go-go dancer. Andy, yeah. Let's see. Can I find this on YouTube? Shoot, there it is. Yeah. There's I'll share with you the podcast that I was listening to while I was doing some construction this weekend. But it's not for kids. I'll put it that way. But check that out. I think you'll enjoy it. If you like kind of off-kilter podcasts, a little bit cynical, but, you know, well-researched, real stuff, check it out. Yeah. I don't think I've gotten to part 2 yet. But yeah. Yeah. And Gamers Tavern says, couldn't pay his bills as an adjunct, so nothing's changed in the last century. I know, right? I have a song about that, by the way. Maybe we'll play it if we get closer to our sub goal for today. Or for this week. Maybe I'll play it today if we get to say... If we get to 50, I'll play you that song. But yeah. Lenina says, everyone has something that they are amazing at. I've been humbled numerous times by people who didn't appear particularly bright, but they helped me with exactly the right thing. Yep, Lenina. Yeah. Every human being on this planet has got some kind of thing that makes them special, makes them worthwhile. Sometimes it takes just a little bit of work to find that thing. But everyone has intrinsic value as a human being. People like Einstein are celebrated because, well, shoot, he found that thing. He couldn't wash a pair of underwear to save his life, apparently, but... Relativity? Yeah. Thanks for your work. Oh, thank you, Cheerful Bloke. I appreciate you. Thank you. Yeah. And Young Black Economist has got good advice there. Holy cow. Yes. Find one thing you like, says Young Black Economist, then just try to be average. If you are just average in what you're passionate about, you will find yourself in the midst of people who can uplift you and can pick you up. Absolutely. Yes. A big part of advancing in a field is just like being around people who are better at it than you are. And you'll learn from them. You will be elevated by just being around those people, hanging out with them. It's a big deal.
You need to take some
you
of
know?
your own advice. Aren't you the man who told me to live every week like it's Shark Week, and that nothing's impossible except for dinosaurs? Don't give up on life.
Oh
son.
no.
Wow.
Harass, thank you for the 27 months of support. I appreciate you, Harass. Thank you, thank you. Yeah. 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 Echidna says, now for the next question, where do we start looking to find that thing? I mean, Echidna, you gotta go out and do stuff. You know? I was very lucky. We'll talk about this next week. On my birthday, actually. My birthday's next Tuesday. We'll have a special birthday stream. We'll talk about this on my birthday, about my childhood a little bit. I'll show you some pictures of when I was a kid. Various dinosaur stuff. I always knew that I was interested in dinosaurs. That's been a constant feature in my life. It's been my Polaris, my North Star, you know? So I was very lucky to find that very early on. And some people live their whole lives without finding what they're passionate about, you know? And some people are passionate about many things. But I think if I could give you one piece of advice about finding something that you're passionate about, this goes for everybody watching right now. You have to kind of spend time with yourself, understand yourself a bit. Pay attention to your feelings. Recognize them. That takes work. And just go out and do stuff. Try different things. Hang out with different people. See what speaks to you. See what makes you happy. And for some people, it's tougher than others. Like many things in life, you know? But go out and do stuff. Like outside. Away from the computer. I know that's verboten. We're not supposed to say that on Twitch, but go out away from your computer if you can and go out and do stuff. Step outside of your comfort zone. And you know, see what speaks to you. Yeah. Anyway, yeah. And as that for Poet, I feel like sometimes it finds you. I mean, it kind of does. Sometimes you just like get sucked into something and it's like, holy cow. Wow. Sometimes it's something that like you just try out and then it just snowballs. It just kind of takes on a life of its own. That's what these streams were for me. You know? I decided to try live streaming in May of 2020 because I thought, this might be a cool avenue for science outreach. I don't like YouTube very much. Never worked out for me. Let's try this Twitch thing. And then, holy cow, here we are today. You know? So, yeah. Yeah. Lenina says, absolutely step outside your comfort zone. I did when I got my current job, and it was an incredible change for me. There you go, Lenina. Very nice. There's a story of raucous success there, Lenina. Good stuff. And thank you, Alice66, for the 300 bits. I appreciate those very much. Thank you, thank you. Good stuff. Good stuff. Yeah. Fight the fight. Yeah. There you go, Peter Steves, I guess. When it's appropriate. Amelia Bedelia says, the computer called to me. Yeah, for some people, computer science is their passion, their calling. That's what they're really good at. Yeah, that's not the case for me. I spend too much time on the computer and I want to bite my own head off. I need to go outside, be in nature, you know? Go for a walk, see some birds. Go walk in the woods, that kind of thing. Different strokes for different folks. People are different. You know, no two people are exactly the same. Even identical twins, not actually identical. Different experiences, different gene expressions. You've probably everyone in chat knows a pair of identical twins who've got different personalities, different habits, different preferences, etc. You know? So yeah.
Here's something stranger than science fiction. Prehistoric fact.
And Prodigal Ghost, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Alas, the return of the Prodigal Ghost. Cheers. It's good to have you here. Yeah. And, yeah, I was lucky. Orchestran, that is lucky. Music is your passion. You were 4, climbed up on a piano stool, and started to play songs you were hearing around you. There you go. There you go. Yeah. Yeah. Anyway. Speaking of finding one's passion, well, first, let's take a real quick look at our 3D printer. Looking good so far. Our horseshoe crab is coming along. It's gonna look, well, right now it looks like this, I guess. Like that? Is that right? Yeah, basically. Yeah, like that. But it will continue to build and build and build until we get a full-on horseshoe crab carapace. Do we call it a carapace in a horseshoe crab, a genus Limulus? Carapace, like on a turtle? What do we call it? I don't know. Anyway, that's going. Why don't we go back to... Speaking of people who followed their passions, here is an old documentary.
Up to the Prodigal Ghost. They have given 346 gift subs in the channel.
Well, holy cow, Golganak. Thank you for that gift sub to Prodigal Ghost. And welcome, Prodigal Ghost. Enjoy not having to watch any ads here for the next 30 days. Welcome to the community. Yeah.
In all the world, there are fewer than 40 full-time dinosaur paleontologists.
Lordy.
3 of them are leading this expedition.
Thank you, Lordy. Brilliant.
Lordy just gifted 5 subs.
I appreciate that very much, Lordy. Thank you for those 5 gift subs. That is excellent. Look, we're now at 37 out of 150 for this week. Oh, boy. Thank you, Lordy. If we get to 50, I'll play you some ukulele today. We'll see. That's only 13 away right now. Yeah. Yeah. Anyway, we started watching this a little while ago. This is from 1977. You'll see some dinosaur paleontologists here. We're very young. Oh. Except for Poet. Thank you for those 5 gift subs. Thank you, thank you. That's
Zephyr
real good
Poet
stuff.
Just changed things with those 5 gift subs.
I appreciate that very much, Zephyr Poet. We only 8 left now. 42 out of... If we get to 50, we'll do some ukulele songs in a bit. Yeah. Let's get to the 50, says Zephyr Poet. Thank you, Zephyr Poet. Yeah. We are so close, Lordy. Lordy, by the way, how was your stream? I think I asked you, you're probably busy. Wombat hole. Thank you for those 5 gift subs, Wombat. I appreciate
Wombat
you.
really wants ukulele with those 5 gift subs.
Good stuff. Thank you. Look, 3 away now from 50 out of 150. Just 3 away. I've got a feeling we might have some ukulele here. Feeling confirmed. Calamity now. Thank you very, very much.
Calamity now is getting serious with those 5 gift subs.
Really appreciate that, Calamity. Thank you for that. That is excellent. Thank you very, very much. We are going to have some ukulele in a little bit. In fact, should we do that right now before we get to our little video? I said we would play a song about, well, about adjuncts and underpaid scientists. Let's do that. Let's do the Dinosaur March, and then let's do Jolene after that. How does that sound? Yeah. Here. This will just be a couple minutes. So if you're not, for whatever reason, if you're not keen on the idea of live ukulele songs, you just have a couple minutes to wait. But let's change our category real quick to music. Yeah. And let's take out the old ukulele here. There we are. I feel like it's been a while. There we are. Let's make sure she's in tune. Everything is a little flat. C string a little flat. G string a little flat.
Gifted a tier 1 sub to Crit in 2014.
Even the A string is a little flat. Usually the A is solid. But anyway. It's all fixed now. Let's do the Dinosaur March, and then we'll do Jolene, shall we? This is as a thank you to everybody. Jody Fish, thank you for that gift sub. Look, we're at 53 out of 150 now. Beautiful. Thank you, Jody Fish. This first song, I used to play this for my students. They loved it. And I learned this song from the music teacher at the school I used to teach at.
One of the most remarkable animals that had ever existed.
J Sam, thank you for the 3 months.
One of the most famous is a dinosaur.
Appreciate that, J Sam.
Magnum D Boldest 1
Look at all of those. Holy cow. And you've got a paleontologizing one in there. Thank you to Ios for commissioning that emote for me. Good stuff. J Sam, thank you for the 3 months of support. I really appreciate that. Sometimes I wish that she wouldn't read all of the emote names out loud, but maybe that's something we could take up with Moobot or Nightbot or whoever this is. Anyway, this song, I used to play this for my students all the time when I was teaching full-time, and this is their very favorite one. I learned it from the music teacher at the school, and then I decided to make some modifications to make it a little bit more paleontologically authentic, and goes like this. Many, many years ago, before the people came, the animals upon the earth, they did not look the same. They lived for 170 million years, but now they are no more. How did I lose it? More. They were the dinosaurs. Let's start that over. Many, many years ago, before the people came, there we go. The animals upon the earth, they did not look the same. They lived for 170 million years, but now they are no more. That's weird. They were the dinosaurs. Apatosaurus, Diplodocus, Stegosaurus, Allosaurus, Ankylosaurus, and Triceratops, Tyrannosaurus Rex. Let's do that verse over again, because I forgot the fingering for that for a second. Many, many years ago, before the people came, the animals upon the earth, they did not look the same. They lived for 170 million years, but now they are no more. There we go. And they are no more, except for birds, of course, because birds, as we now recognize, are living dinosaurs. Dinosaurs, strictly speaking, never went extinct. Not completely. There was one lineage called aves that survived that asteroid impact at the end of the Cretaceous period and have since diversified into over 9,000 species of living birds today. So not only are dinosaurs not extinct, but you could make an argument based on species count that we're still living in the age of dinosaurs because birds, being dinosaurs, outnumber mammal species roughly 2 to 1. So is this the age of mammals or is this still the age of dinosaurs? They were the dinosaurs. Apatosaurus, Diplodocus, Stegosaurus, Allosaurus, Ankylosaurus, and Triceratops, Tyrannosaurus Rex. So that's the first verse that I just sang twice, and the chorus twice too. There wasn't a second verse when I first learned this song, but I wrote my own, and it goes like this. We can learn about these awesome beasts by studying their bones. Skeletons under the ground that partly turn to stone. We dig them up and we clean them, and we raise them off the floor to build a dinosaur. Apatosaurus, Diplodocus, Stegosaurus, Allosaurus, Ankylosaurus, and Triceratops, Tyrannosaurus Rex. There you go. That's the dinosaur march right there. Now our next song is a song devoted to all of the overworked and underpaid scientists out there trying to negotiate this rat race that we call academia. Too many scientists nowadays are all scrambling for the same very limited funding, the same grants, the same opportunities. Academia and the current academic milieu, the over-financialization of the university system in particular, has pitted scientists against scientists, and it's not pretty. This song goes out to all of those underpaid scientists out there just scrambling to try and make ends meet. The song is called Jolene. It goes like this. Jolene, 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 I'm begging of you, please don't take my grant. Jolene, 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 Jolene. Please don't take it even though you can. Your research is impressive stuff. Surely it is good enough for tenure. You don't need the funds, Jolene. Your papers are exemplary. Citations, you got so much more than me, and I cannot compete with you, Jolene. Jolene, 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 Jolene. I'm begging of you, please don't take my grant. Jolene, 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 Jolene. Please don't take it just because you can. And I could easily understand how you could easily take my grant, but you don't know what it means to me, Jolene. And you could have your choice of dough, but I could never get funds on so short notice. It's my only hope, Jolene. Now I had to have this talk with you. My research goals depend on you and whatever you decide to do, Jolene. Jolene, 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 Jolene. I'm begging of you, please don't take my grant. Everybody, thank you for sitting through that. And thank you for this incredible support today. 53 subs today. Holy moly. We are well on our way to our weekly goal here. Thank you for that. Everyone who contributed, you know who you are. Thank you from the bottom of my heart. Thank you very much for your support. Making me feel much more like Jolene herself than like the singer of that song. Yeah. Roland Elliott says, I'm listening with headphones while cleaning and laughing. My family thinks I've lost it. And maybe they're not wrong, Roland Elliott, but I appreciate you. Thanks for being there. Yeah. Yeah. Anyway. Yeah. And see you later, Thagomismer. Hey, you feel better? Thanks for being here. Yeah. Anyway, let's check out this old documentary from 1977 from PBS Nova, The Hot-Blooded Dinosaurs, 1977. We started watching this last week. Tom Holtz actually posted about this. Quite recently. Where was that? That's actually how I found this. So, paleo salute to Tom Holtz. Where was that? Hang on a second. I know that face. Is that Willie Frymouth? Yeah, holy cow. Willie first came to Montana as one of Dave Verricchio's master students, I think. Like, a month before I left Montana. We're like two ships passing in the night, and then, they bumped against each other, but it's okay. Nobody got hurt. Anyway, what's he up to? He's working with Lindsay Zano now. Lindsay Zano is a real Jolene, if you know what I mean. She gets all kinds of grants. Holy cow. Lindsay's been remarkably successful. Yeah. Anyway, so Willie is probably one of Lindsay's doctoral students now. Good for him. That's super cool. Very, very cool. By the way, Lindsay Zano, her crew, when it wasn't E-Guy, it was, shoot, what was the Speedo's name? E-Guy was a different dinosaur, right? No. It's slipping my mind. The little ornithischian dinosaur. Eoni is what it was called. A different four-letter name that starts with an I. Iani Smith-Eye. We talked about this dinosaur. Remember this little guy? Lindsay Zano and her crew dug this up, published on it. Yeah. Anyway, and now Willie is part of that group. Very cool. Yeah. And he's out there in Mongolia. Super neat. Very cool stuff. Anyway, I was scooting through here because Tom Holtz had found this video. There we go. He says, the granddaddy of dinosaur documentaries, the Horizon/Nova hot-blooded dinosaurs. Behold how young everyone is. Yeah. Well, let's take a look. Let's embiggen the volume a bit. Y la troca, the truck.
These are the prairies of Alberta in Western Canada.
Alberta.
70 million years ago, dinosaurs lived here.
They still do, but we didn't know that back in 1977.
Their
Didn't know
remains
birds
are
were
found
dinosaurs
along the
yet.
valley of the Red Deer River, where wind and water have eroded the soil.
Hey, Joe 3E, how are you doing? Welcome, welcome. Yeah.
It's to these badlands that dinosaur hunters come.
Look, don't hit the camera. Oh.
As they weather out of the ground. Dinosaurs were the largest and most successful creatures that ever lived.
You
They
betcha.
dominated the Earth for 120 million years. Trying to explain their success has always caused fierce debates. In this program, we present the views of one group of paleontologists who think they've found the reasons for it. Today, dinosaurs are being given...
Oh, and Joe 3E, thank you. Shoot. We forgot to change our stream category, huh? Let's bring this to La Ciencia y la Tecnología. There we go. Yeah. Yeah, that'll put us right here above Roby Tech. Well, that's gonna be nice. Well, well, well. Not too shabby. Let us return to the hot-blooded dinosaurs. Yeah. Hey, Reanimated Bit, welcome back.
Like. How did they live? In Hollywood, at least, they thought they had the answers.
This is from 1925's The Lost World, and animated by Willis O'Brien, who would later go on to do King Kong in 1933. This is a silent film, so these sounds are all added. There's a Agathamus, which is a dubious genus of horned dinosaur, being set upon by a Tyrannosaurus, and then
Scientists making sense
yoink!
of these monsters
He grabs a
with
pterosaur
strange
too.
sounding names has always
Why
been
not?
difficult. Stegosaurus, a plant eater. The gigantic brontosaurs, the largest dinosaurs of all.
We call them sauropods nowadays.
Iguanodon, one of the first discovered. The terrifying Tyrannosaurus rex. All these creatures have been argued over ever since they were first discovered.
This is great.
At the center of one long-running debate.
Very aged, but I like it.
Like the brontosaurs.
Yeah. Oh, and here's Bob Bacher again. I think this is about the time that we stopped last watch through last
He's
week.
been interested in the way ideas about these creatures have evolved.
This is a sauropod dinosaur. Well, I generally draw sauropods or any other type of dinosaurs. First, a quick sketch of the outlines of the bones, and on that I add the major muscles, model of them as the fossil bones indicate. And you can make quite an accurate model of a dinosaur or any other fossil animal because the size and shape of the muscles is indicated by the marks on the bones.
Yep. He's a very good artist. I agree, Zucchini Puff, yeah.
About
yeah.
1905...
Say what you like about Bachert. Good artist.
There was some strong criticism of some of the research done on American sauropods by European scientists.
And this might be Bachert pre-transformation, back when he was still, he still belonged to that religious sect. Seems much more reserved right here. He didn't cut his hair, anything like that. Yeah. Anyway, I've heard stories, but yeah.
According to the Europeans, the sauropods should be restored like true reptiles, with their upper arms and their upper legs splayed out to the side, like an enormous lizard. An American paleontologist, Holland, pointed out we run into serious difficulties with our sauropods if we put the upper leg bones splayed out to the side.
They don't
like
work that way.
It's a sauropod from a rear view. Great flaring pelvis, rather deep in the lower pelvic bones, but the ribs are even deeper, extending way below the pelvis. You
have to go down into the ground.
You've got an animal whose rib cage goes way beyond his feet. And Holland points out, you then have to dig a trench for the dinosaur so that he can walk around like a lizard with his deep rib cage. And Holland suggested this is one reason sauropods went extinct, because it's bad mentally and by.
So this is, yeah, it was the Germans, I think, who suggested this. It was like Tournier et al. There we go. Yeah. So here's a picture of a poor Diplodocus right here. Yeah, work of Hay, an American paleontologist, and Tournier, a German paleontologist. Believed it had a sprawling posture. As we see, this is totally unrealistic. In fact, dinosaurs are able to walk with fully erect limbs. So yeah, they would need to find like big trenches to walk through. Like some sort of slow-moving dinosaurian bobsled. It's basically like a dinosaur on rail. It does not make any sense at all. Yeah. Do we have any proof that dinosaurs didn't dig trenches? Plenty of proof, Reanimated Bit. In the sense that we've got footprints, we've got trackways of these animals. We know that they didn't do this because their feet are very close together in those trackways. So by examining fossil footprints of dinosaurs, we can tell how they actually held their limbs, which is pretty cool. Again, it's how we test ideas in paleontology.
Biologically, to run in a rut. Well, that's mostly nonsense. Getting back to reasonable restoration of a sauropod, suggested by American scientists that these animals were so big.
There you go, Reanimated Bit, yeah.
They couldn't possibly support their weight.
And thank you, Reaper Extra.
They had to use water to buoy themselves.
Thank you, Reaper Extra.
22 gift subs in the channel.
Really appreciate that. Thank you, thank you. Good stuff. Thank you, Reaper Extra, for your support. It means a lot to me. It really does. Thanks for that gift sub. Reanimated Bit says, okay, so with this evidence, I would change my mind and how I previously thought. Like a true scientist. Reanimated Bit. Nice. And Asazi, thank you for the 8 months of support, Asazi. Thank you, thank you. Good stuff. Yeah. Here, let's go back just a titch.
Getting back to reasonable restoration of a sauropod, suggested by American scientists that these animals were so big, so enormous, they couldn't possibly support their weight on dry land. They had to use water to buoy themselves up. And the long neck was for breathing.
And hang on, Paleo Entertainment. Sorry, I missed your message earlier, but how are you doing? Yeah, pot-bellied sauropod. I mean, that's the proper rib cage for a sauropod like that. It's just they didn't hold their limbs that way. They hold their limbs directly under their body to support the weight. Yeah.
Just the tip of the head exposed above the high water mark of the lake or swamp. There's a problem with this restoration, pointed out a couple of years ago. The nostrils are here, the lungs are here. The pressure of so many meters of water would collapse the lungs. It's virtually impossible to draw air down through here.
Like a billionaire's submersible. Just
strengthened cartilage or
can't do
bone
that.
tubes that whales have to prevent the windpipe from collapsing.
Thank you, Paleo Entertainment. Yeah, I'm glad to have you here.
Arguments continue because evidence is scarce. What evidence there is comes from expeditions like this one 50 years ago to the Red Deer River in Alberta.
This is good footage.
These hills were once the richest dinosaur hunting grounds.
I might have to snag some of this for an
In their
upcoming
heyday, they saw a kind
cold
of
open video.
paleontological gold rush. Often, all that was found was a single bone, and getting it out sometimes jumbled the remains still further.
Would definitely knows. There you go, Golganek, yeah. Oh, very cool, Zucchini Puff.
These early collectors were often less interested in understanding dinosaurs than in getting their specimens back to their museum ahead.
And what valley was this? I was not paying as close attention as I should have. Was this the Red Deer River in Alberta, Canada? Because holy cow, very few valleys on this planet have as many dinosaur fossils that have been dug from them as the Red Deer River Valley. Yeah, it's got a legendary place in dinosaur paleontology. You bet.
Of their rivals. Competition was fierce. These early collectors were often less interested in understanding dinosaurs than in getting their specimens back.
Patrick Crusader says this video really shows that scientists don't have to be smart. If there's one idea I get across in today's stream, I hope it's that science is not as lofty and like unattainable as you might think that it is. If you're dedicated and curious and driven, you can be a scientist. I'm not a big believer in ideas like, raw IQ, raw intelligence. I've met so many people who claim to have extraordinarily high IQ, and these people are just clueless individuals. And then I've met plenty of people who are, kind of from closer to my social background. Maybe they work a blue-collar job, or they're just regular everyday folks. And I'm like, if you'd been dealt a different hand, you could have been a scientist. It's a little bit gross sometimes how much, even to this day, science, like becoming a scientist, is very much determined by like your social class, like how you grew up. So many scientists that I know nowadays are, their parents went to college, There have been so many times when I've been speaking with colleagues at various museums, at various universities, and, we're just out to dinner, out at the bar or something like that, and be like, talking about our, how we first got into science, that kind of thing. Be like, oh, well, I wish I had some, like, fancy, like, chamber music to play right here, but I don't have that queued up. Maybe, let's see. There we go. Talking with somebody, and maybe she says, well, I first realized that I was interested in science when I was at our summer estate. And, my grandmother, who has 3 PhDs, she pointed out to me the intricacy of these orchids that she was growing. I was fascinated by this. And that sparked my love affair with the natural world. And it's like, oh boy, okay. I liked reading dinosaur books when I was a kid. My parents didn't go to college. Yeah. And it's tough for people of, my social standing sometimes. Like class makes, especially in the US, makes a huge difference and how far you can advance in the sciences, unfortunately. And hopefully that's something that's changing. But I think the reason I talk about this, the reason I bring that up is that so many of the people that you see in academic positions, people who become scientists, in one way or another, they had a leg up. Doesn't necessarily mean that they're smarter or more capable than anybody watching this broadcast right now. If you had parents who went to college, you're already... That's a huge leg up right there that you got. You know? Yeah. Ken, how are you doing? Welcome, welcome. For yourself and the lower classes. Oh, no. There you go, Ken. Yeah. But yeah, I don't know. It is cool in that paleontology is one of those fields where it's not quite as pronounced, I think, as in other scientific fields. Because paleontology requires things like, well, it doesn't require, but often involves things like fieldwork. And if you're very comfortable in the outdoors, which many people in the upper classes are not, then that, kind of gives you a certain advantage in paleontology. So I don't know. Yeah. Yeah. Definition of intelligence equals nailing Jello to a tree. There you go, Golganek. Yeah. And PMC. Yeah, SV Harkin knows what's up. Yeah, professional managerial class. Yeah. And Maddie Holmes says, you can sometimes tell which college professors have never been out of an academic setting since a very prestigious preschool. Oh, yeah. Yeah. Shoot, it's kind of funny. Some of the preschoolers that I taught, like that was I don't know if it was a prestigious preschool, but it certainly cost a pretty penny. They paid me very well to be a teacher there, and I was very appreciative. But yeah, that's totally a thing. Yeah. Anyway. Yeah. And you've been lurking all night? Well, it's great to have you here, Ken. Welcome, welcome. Yeah. Yeah. Ken, like me, somebody who might come from a slightly non-traditional background academically, but somebody who's making strides in paleontology, and that's kindred spirits there. Yeah. And Maddie Holmes has got some insight here. Thank you, Maddie Holmes. Welcome back. Maddie Holmes says, archaeology is a weird mix of super blue-collar ditch digging by hand, like I do. And then some of the highest level people are those who come from the most connected people. People in museums are often the ones who are very high socioeconomically with money help. Yeah. Paleontology is kind of the same, Shoot. Let me show you. Yeah. Here. Yeah. Here's my old boss, Jack Horner, talking about his background a little bit. Yeah, he did not come from lofty beginnings. We'll say that.
Okay. The whole point, I guess, is I don't know how I got here, why I'm standing up here. I come from Montana, And I come from a town called Shelby, Montana, and here's a picture of it.
Yeah, that's a good point.
This
About
large
Osborne and Brown.
thing that's in the picture here. Shelby this was 1923. This was obviously before I was born, but I think the whole town was dyslexic. This is a boxing stadium.
So Jack here is dyslexic, and that's what this talk is about. I'll give you the link to it, actually. If you have any dyslexic viewers, you might find this really interesting, or anybody who's involved with education or anything like that. That's interesting stuff. Yeah.
Stadium. This was where they held the World Heavyweight Boxing Championship in 1923 in a town of 500 in the middle of Montana. No kidding. That's it. So
and there you go. There you go, Ken. Yes.
Well, as you can imagine, very well. But I have circled there the building where the high school in the town, where 5 years after this picture was taken, my father graduated as a valedictorian.
That's Jack's dad.
Imagine just saying that, you probably know that he and I didn't get along well.
So we're talking. Shoot, we were talking about what it takes to be a scientist, or maybe what it doesn't necessarily take to be a scientist. You don't have to be a super genius to be a scientist. You just have to find your thing to be a great scientist and work hard at it. That's what Jack did, and he'll tell you about it here.
I was born, and
Confused Echidna says, so people with learning difficulties can succeed in science fields? Absolutely, Confused Echidna. 1,000,000%. That's what this talk is all about. Yes.
And there's my first.
Here.
I was born. And,
he was born.
And there's my first house on the left there, a tent. And I pretty much live in tents. My first house.
I can relate. I live in tents for multiple months out of the year, too.
On the left there, a tent. And I pretty much live in tents ever since.
Although he's saying at this point, Jack doesn't, when he goes out to the field, he doesn't sleep in a tent anymore. I've never seen Jack sleep in a tent. He's got like a camper shell for the back of his pickup truck, and he sleeps in that. Which, good on him for that, you know? Shoot. He's spent maybe more time in tents than I have spent alive on Earth at this point. Again, because I'm 21 years old, right? Right, chat? Right, chat? Right? Yeah. Yeah.
So there are sort of two stories here. One is the way my father saw it. And as far as he was concerned...
I do turn 21 next week. Yeah, thank you, Ladina. You remembered.
For me until I was 5 years old. And like everyone else, at the age of 5, or just a little over 5, I went to kindergarten and flunked out because I couldn't figure out the blocks with letters on them. And then, according to my father, at the age of 8, he tried to teach me algebra, and I still, obviously couldn't read, so I didn't do well there. And then I went through, like everyone else in this room, I'm a little suspicious of the non-dyslexics in here. But I'll get that out later. All right, so I'm just really curious as to why you're here. I mean, seriously, unless you're trying to get our secrets from us.
Claire Burr makes some really good points there. Prerequisites for being a scientist are curiosity, Curiosity 101, beginning open-mindedness, facts versus opinions, and a basic understanding of how to remember that not a single question asked in earnest can be considered a dumb question. There you go, Claire, yeah. Yeah. I agree.
Anyway, so I went on and did poorly and had lots of report cards that said lots of things about, like the other report card we were looking at. And I finally graduated from high school with a D minus, minus, minus. And the teacher said to me, "This means that you have failed, but I never want to see you again." I was happy. That was good. So then I went to college. I went to the University of Montana. At that time, you could get in if you had a high school diploma. And I entered in 1964 and I flunked out in 1965. And upon flunking out, I was drafted and I went to the United States Marine Corps, which only drafted for 1 month.
I was actually talking about this with Ken over the summer. Yeah. Apparently this is not entirely true. The Marine Corps has drafted people into the Marine Corps. So, shoot. The U.S. Marine Corps, for those of you who are not from the States, is a branch of the United States Military Armed Forces. Military Armed Forces. Anyway. The Marines are... You can kind of... Well, don't ever say it to a Marine, but they're kind of a branch of the U.S. Navy. But they're like the U.S. Navy ground combat forces, sort of. They get transported by the Navy, so they're, sometimes they're aboard ships, but then they're like a kind of elite fighting force on the ground, boots on the ground, the Marines. Yeah. Volunteer force. 99.999% of the time, all volunteer. You've got to volunteer to join the Marine Corps. There's supposed to be an elite coterie of fighters and logistics specialists and everybody else, It's like, yeah. So normally they don't do conscription, draft people in, but Jack says he got drafted by them in 1966, and I'm sure he's got the papers to back that up. Navy infantry. There you go, confused a kid. Yeah. Yeah.
And upon flunking out, I was drafted, and I went to the United States Marine Corps, which only drafted for 1 month in all of its time.
Apparently this, I don't know. If you're curious, chatters, you can look this up. I think the Marine Corps has actually done very brief periods of drafting throughout its history, but they're a volunteer force by and large. Yeah. And Recon Battalion, yeah, MacNat, yeah.
So, I was not only dyslexic, but unlucky.
Yeah. Marine biology, there you go. Carell Casey, yeah. See, the things you learn on Paleontologizing channel. The Marine Corps, hoorah. And marine like marine biology. Yep. Marine, they both have ties to the sea. That's what that word means. You got it. I'm glad you're able to make that connection.
So,
yeah.
So that was 1966, and then I came back, and then I went back to college, and according to my father, in 1973, I had flunked out of college 5 times and 7 times in 5 years, and I was 27 years old. I was married. I was a truck driver, and as far as my father was concerned, that was the end of my life. He wasn't even going to hire me to work in his gravel plant, which was okay. That was all right. But that's not really how I looked at it. I sort of had a different view of my life. When I was...
I want to point out, this is not... this is in the YouTube video itself. I didn't crop this or anything. This is not my fault. Whoever put this video together, that's their fault, I suppose.
8 years old when he was trying to teach me algebra. I actually found my first dinosaur bone that year. And that was a pretty big occasion for me.
Thing for your birthday? Anytime. Claire, send that to me anytime. Yeah. Appreciate you, Claire. Thank you. Here we go.
When I was 8 years old, when he was trying to teach me algebra, I actually found my first dinosaur bone that year. And that was a pretty big occasion for me. And I went out, my mother would take me on drives and take me out to the sites. And so I would go out and collect dinosaur bones, even though I was failing all of my classes in school. And when I was 12 years old, I built an exhibit in our library, and it's
look at Jack, age 12. He might not be exactly 12 there, but yeah, that's pretty cool.
Still there. And so
it's still there.
Go to the library and read all the books, and not read them, but look at all the pictures, determine what I thought I had, and label all the fossils. And then, and I continued to do that through high school, and during when I graduated from high school, I won the science fair, and that was actually how I got to college. I was invited, and so I went in 1964, and I studied geology, zoology, anthropology, and botany.
Oh yeah.
And I actually took all the
good way to become a paleontologist.
Were offered in all 4 of those departments. I mean, when you flunk out every quarter, doesn't really. So here's the key. Now this is worth telling your students. The key is that if you change your major after you've been kicked out, then those people in that department don't really know. And so I would change majors pretty constantly.
So again, you don't even necessarily have to do the best in school to become a paleontologist. It helps oftentimes, but if you do have something like dyslexia that makes it particularly difficult for you, if you have a learning disability, well, take it from Jack Horner, you can still become a paleontologist. You can still make extraordinary contributions to the field of fossil science.
But while I was there, I also learned how to. Don't look at the trousers. It was the 60s.
Smile it on.
So anyway, I learned how to put skeletons together, and it was pretty cool. So I actually learned quite a bit. I also excavated my first dinosaur.
In 1972.
Skeleton. And so from my perspective, in 1973, I had learned an awful lot about geology and zoology. I'd completed a scientific research project. I was married, and my outlook was pretty optimistic. And I was applying for work in museums. And 2 years later, I was hired to work as a technician at Princeton University. Now, a technician, I didn't have a degree, as you probably could tell. I had a high school diploma, and that was it. So anyway, I was hired by Princeton to clean fossils. And while I was there were signs around on the campus.
Prodigal Ghost?
Would you rather go to
I can relate to that.
Read a book?
Yeah.
Some other weird questions.
Hang on.
I went and asked about it, and they told.
Oh, this is a turning point in Jack's life right here. Sort of. Well, not really, but we'll replay it anyway.
To clean fossils. And while I was there were signs around on the campus, and one of them said, would you rather go to a movie than read a book? And some other weird questions, and I went and asked about it, and they told me that I was dyslexic. I assume everybody knows here it doesn't matter if somebody tells you that, right? I mean, you can't read any better.
Yeah.
Anyway, so I thanked them, and I went back to work. So I started Princeton in 1975, and then in 1978, a friend of mine, Bob Makala, who's there in the picture, he and I found a nest of baby dinosaurs back in Montana when I was back there on vacation looking for stuff. And the baby dinosaurs, it was the first time people had actually seen evidence that dinosaurs cared for their young.
And so this is a huge deal. I don't have to tell you about this. You probably know already. But the first evidence that dinosaurs cared for their young, this was a huge deal. Yeah, and it's because Jack found what he was interested in. He found his thing. And if you want to be a scientist or you want to be any sort of, person doing your thing, you got to find what that thing is. I got really lucky where my thing was obvious to me from the beginning of my life, basically. I always knew I wanted to be a paleontologist. I always knew I was interested in dinosaurs. But everybody watching right now, you've got some kind of thing, Maybe it's multiple things. I don't want to oversimplify it, but there will be something that you are really, really good at. Maybe it's a combination of different things, different fields that you can bring together. But there will be some little niche that you can carve out for yourself that is uniquely you. So don't be afraid to get excited by stuff. To go out and find what enlivens you, what sets your brain alight. Because it's out there. Yeah. Yeah.
And so a year later, I published my first scientific paper in the journal Nature.
And there you go, Prodigal Ghost. Translate science speak to layman very well. Run with that. Yeah.
We found a lot of stuff.
What embiggens you? There you go, Matty Holmes.
We found the largest concentration of dinosaur bones in the world.
Yeah.
Estimated at 115,000 skeletons.
Holy cow.
Dug them all up yet. But
by the way, this is Maiasaura here. 115,000 skeletons. Jack thinks that they were killed in a volcanic eruption. The pyroclastic flow would have killed them all. It was actually portrayed in Dinosaur Planet back in, 2005? Here we go. Something like this. There's a Maiasaura there. This is, oh, there's that volcanic eruption. So these are the dinosaurs they've got about 100,000 of, probably. Egg Mountain is still an active site, Golganek. Yeah, not as active as it used to be. But, Jacket doesn't work there anymore. That's part of it. Whoa, what? What's going on here? Uh-oh. Anyway. Volcanic eruption. Oof. Yeah, nasty stuff. So we've got evidence of multiple eruptions like this all throughout the age of the dinosaurs. They laid down layers of ash, which could be really helpful to us because they're easy to date. They've got zircons in them that are really, really, well, they've got radioactive ashes, but also zircons too. Really useful for dating. Figure out exactly how old those rocks were. Anyway. And pyroclastic flows. Oh, hang on. Rose Sand says that science talking man sounds like Will Scarlet from Sherwood. I don't know who that is, but this is Christian Slater narrating this. Yeah. Is that the same actor? It's the same guy, Rosand. Yes. Oh boy. This is what happened to this poor Maiasaur. This is why I'm showing you this clip. Pyroclastic flow. This is the stuff of nightmares here. This is... Oh boy. Yeah, you better get out of there. They're not going to be fast enough. Ugh. Yeah. Yeah, get out of there. Oh boy. Oh boy. Truly nightmarish. There were literally thousands of Maiasaura. Probably hundreds of thousands who were killed by this one event. Look at that. Yeah. Uh. Yep. Yowza. It's wild stuff. I mean, yeah. Probably 100,000 Maiasaura, duck-billed dinosaurs. For those of you who don't know this critter, there you go. Maiasaura. Right here. There's a really good one there. I like that a lot. Maiasaura. Duck-billed dinosaurs. Yeah. That is what Jack found there.
Estimated at 115,000 skeletons. We obviously haven't dug them all up yet. But I was at Princeton, and at that time the museum in Montana, the Museum of the Rockies, where I work now, stopped by and said, you know, leave some. You're finding so many dinosaurs. Leave some here for us. And I said, I'll tell you what. I'll leave them all here if you just hire me. Because Princeton's very nice, but I don't know. When you're born and raised in Montana, New Jersey doesn't doesn't cut it. So they did.
No offense to
hired
New
me,
Jersey.
And in 1982, I went back to Montana as the curator of paleontology.
Was it like Pompeii ashes? Worse. TMK, worse. Yeah, like Pompeii, probably times 10. Yeah. And cephalime, yes, it is indeed Maiasaura rather than saurus to indicate female from mother. Yes. Indeed, cephalime. There's something like 8 or 9 different dinosaurs that have sora instead of soras to indicate femininity. Maiasaura, Buganasaura, Gasparinosaura. There's a plesiosaur called Anningsaura, who I'm going to be 3D printing before we celebrate Mary Anning's birthday next May. Oh, and there's a few more, and I can't remember them right now. But anyway, yeah. Yeah. And thank you, Cheesemo McSello. It's good to see her. Yeah. Yeah. And New Jersey has some great scientists like Balint and Lita. I think they live in Pennsylvania, Kennedy, but sure, there are definitely some good scientists who live in New Jersey. Yeah. Yeah.
And now I didn't have a degree, so I couldn't do anything. I mean, I couldn't, I was the curator. I could.
Well, they live in New Jersey. Oh, okay. Across the river.
Put things away.
Good to know,
But
Claire. Cool.
I was at a university where I really couldn't do much of anything else. But a funny thing happened. While we were working, we found the first dinosaur eggs in the Western Hemisphere.
Yep.
Now, and then, we went on to find quite a few eggs. And I don't know, there's something about dinosaur eggs. Maybe you can explain. We'll have a dyslexic conversation after this, all right? So, dinosaur eggs actually had been found in the 1800s.
Yep.
And so, dinosaur eggs had been found in the 1800s. They'd been found in France. They'd been found and then in the 1920s, they were found in Mongolia, and some were found in China. And I started finding these eggs in the 1980s, and I was the first person to find.
Here's your dyslexic advantage right here. We were talking about different ways to be a scientist, people of different backgrounds becoming scientists, and the advantages or disadvantages that you might have. This is a big part of that right here.
Finding these eggs in the 1980s, and I was the first person to find a dinosaur embryo. A little skeleton of a dinosaur inside the egg. Now, here's our dyslexic question. Dinosaur eggs were found in the 1800s. First dinosaur embryo was found in 1983. What advantage did I have over everyone else in the world for all those years?
The closed captions give it away.
I had a hammer. That's all it was. I had a hammer.
Glue is cheap.
For all of those years, people had. Now, see, this is the problem with reading.
Reading is wonderful. I love reading, but reading is not the end-all, be-all. If you're reading something, you're reading what's been done in the past, And that can constrain you a little bit if you're not careful about it.
Reading is really overrated if you think about it. People had convinced one another that they shouldn't break eggs open because eggs are precious. And so no one ever broke an egg open. A dinosaur egg. I even went to museums and I said, "Can I just break one of your eggs open?" And they said, "No, you can't break your eggs because they're precious." And I said, it's just like having a present that you never open because it's so pretty. Seriously, no one had ever found a dinosaur embryo. So I've gone back now that people saw that I could break them open, and glue is cheap. You can just glue them back together.
I had to grab that clip and add it to our collection there, because Jack has said this phrase before, but it's a different intonation.
Back now that people saw that I could break them open, and glue is cheap. You can just glue them back together. In there's nothing that you can see in my picture there, it's the thing's actually held together with a rubber band. After you break it, you just rubber band it back together again. Anyway, that's, so then, I don't know, I published my first book that year and of course sent it to my
I have that book. So good. Yeah, I don't know if I can find that book in time to be able to show you right now. I've misplaced it recently. I don't know where it is, but I've got it somewhere. Yeah. Control F bookcase. There you go, Claire. I wish. Maybe if I do end up moving, like I might have to do toward the end of the year, maybe it'll be a blessing to do so. I can reorganize my bookshelf a bit better and categorize things. Anyway.
And then we've gone on and discovered an awful lot of dinosaurs in Montana, a lot of new species of dinosaurs, but it was the dinosaur embryos that caught people's imagination and got something. As the University of Montana, the very people that had thrown me out of college 7 times gave me an honorary doctorate.
This is beautiful. Yeah. There you go. Somebody's calling Jack while he's at the pony. Jack, turn your ringer off.
On my 40th birthday. And then 2 weeks later, I got a MacArthur Fellowship.
And that is incredible. A MacArthur, they call it a genius grant. Is Jack a genius? I don't know if I believe in geniuses. But, Jack found his thing. And he ran with it. And I think that's the best piece of advice you could get.
So then they made me a professor. I'm serious. They made me a professor.
At Montana State.
Because I had a hammer. I'm serious. I became a professor. And then I could have graduate students, and I could write NSF grants, and I sent out expeditions all over Montana.
And I was part of several of those expeditions from 2011 until 2014? And then I started working for some other museums. But yeah. 15, 14, 25, 14, I think. Yeah. And Rose Sands is a genius, is just someone who does well at something that gets noticed. So by that logic, yes, he's a genius. Well, there you go. If you'd like to watch the remainder of this talk, we're actually almost all the way through it. Shoot. There's the link right there. Now, let's get back to this documentary from before Jack was considered a genius. This is 1975. I think it was 1977 or 1978 that Jack and Bob Macula made their discoveries at Egg Mountain. So I don't think Jack is going to appear in this, but he appears in basically all the documentaries after this through the rest of the 80s and 90s. Oh, yeah.
To their museum ahead of their rivals.
Anyway. This is good stuff.
In the early days, the fossil bones gathered with such great effort from the earth were the only clues to what dinosaurs had been like. Back in museum workshops,
this is great archival footage.
Effort were needed to prepare
good
the
stuff.
skeletons. Without a plan to work with, The bones were simply fitted together like the parts of some bizarre jigsaw puzzle. There is always uncertainty, yet with careful analysis, the bones can reveal a wealth of information about the long-dead animal.
More Balker here. Is Plateosaurus? No, is it Apatosaurus?
According to Bob Backer, the evidence from skeletons suggests that some of the gigantic sauropods, for example, had rather extraordinary eating habits.
The most advanced sauropods, ones with the most specialized bony structure, are Diplodocus and Brontosaurus. Now, these animals have very peculiar proportions: enormous pelvic girdle, enormous upper thigh bone, very, very short back, powerful forelimb, but a short forelimb, and a tail structure which is just full of muscular processes and strength. Well, reviewing all this evidence, seemed to me that this is a suite of adaptations for standing on the hind legs and tail, rearing up on the body, pushing the neck up, and feeding very high in the foliage. And it was pointed out by the older American paleontologists that right here, on the base of the tail, where it would touch the ground in this tripodal stance, very often you find damaged vertebra in Diplodocus and Brontosaurus, indicating pressure, great weight was applied there. Illustrating that our interpretations of sauropods and our interpretations in dinosaurs in general go through waves of reinterpretation. And some of these waves are rediscovering the very good work, the very logical analysis that had been done by some of the earliest observers.
Dinosaur bones are only...
We've made copies of them. We've laid them out on the beach here in the right position so that each footprint is the right distance from the next one. Front feet, much smaller. Stride length here of something like 8 feet from right hind foot down.
I guess they couldn't actually get access to the original trackway in Texas, so he's doing like a replica here, but yeah.
To right hind foot down again.
It's also from Texas. There you go, Baja. Yeah, there's the femur and tibia and fibula there.
This is a replica of the bones of the animal we think made those footprints. It's the right size, but just a bit lighter than the real thing.
Styrofoam.
Now, here, we've got the femur. That's this bone here.
Thigh bone.
The tibia and the fibula.
Main shin bone.
The lower leg bones. They're from a brontosaur. The animal was about 70 feet long, from his head to the end of rather a long tail.
Are you going to draw it over? Come on, editor.
Just about 5 of the biggest African elephants.
There we go. And notice how the tail is still dragging on the ground. This is 1975. This documentary was made. It was still assumed at that time by many people, including many paleontologists, that these animals still drag their tails on the ground. We now know that's completely false. There are pretty much no dinosaurs that drag their tails on the ground. And we've got multiple lines of evidence that show this. For one thing, the footprints, the trackways don't show drag marks from the tails. If these animals were dragging their tails, you would find those drag marks there in between the footprints, and we don't. The bones are not the right shape also for this kind of curve like that. They're the right shape for them being held straight out behind the animal. Just like the neck is. You know? Yeah. Those are just 2D printed. There you go, HD. Yeah. Yeah. Play.
Smaller than a London bus, a Brontosaurus was a truly enormous creature.
You've seen dogs wipe on the ground? That's a specialized behavior, Wombat Hole. That also often means they have worms.
Finding out involved some rather unusual transport. The dinosaur footprints and leg moves faster.
We've got an amphibious vehicle. We've got a horse. What's going on here?
The left forefoot and the right hind foot moving together.
Yeah.
The right forefoot and the left hind foot. moving together.
I mean, for one trackway like that. We've got
So,
trackways of
100
animals
million
like
years
this
ago,
moving
these
a good deal
creatures
faster.
strolled around at only 2 miles per hour. But what was their top speed? That depends, it seems, on how strong their legs were. Dinosaur bones are fossilized, turned to stone, so bones from present-day animals are tested instead. This one is from the leg of a cow.
You put it on a drill press and just see when it fails. Yeah, in mud, exactly, Ken, right? The substrate, also important. Good point.
Broken. That took 13 kilonewtons. That's just about 1 1/3 tons.
Animation did have the tail not dragging. You're right,
So
Matty
how much
Holmes.
for the
Yeah.
dinosaur? I calculate, scaling up from the cow bone, that the dinosaur bone would have taken just about 40 tons to break. 1 1/3 tons for the cow bone, 40 tons for the dinosaur. Now,
that seems a little
the
low.
The dinosaur goes, the bigger the force that acts on its bones. And I calculate that if the dinosaur had got up to 12 miles...
And he's going to say, oh, if the dinosaur got up to 12 miles an hour, the bones would break, right? These dinosaurs had to move very, very slowly. Again, this is extrapolating the structure of a cow bone to a sauropod bone, like a sauropod femur. And they don't work exactly the same way. You know, sauropods would have had, I suspect, proportionally stronger bones than those of, say, a cow.
miles an hour, the force on this bone would have been just about 40 tons. If the dinosaur had trotted, it would have broken its legs.
So if you're a brontosaur, don't trot.
I mean, that's the thing. Trotting. I'm not an equestrian. I don't know much about horses and what the different fancy names are for how they move. A trot is lower than a canter, which is lower than a gallop, but a trot is faster than a walk, right? Right? Couldn't a patasaurus trot? I don't know. They kind of wouldn't have to. When you're an animal that can move, you know, one stride is 12 feet, do you really have to trot to move that quickly? I don't know.
Right from the beginning, just one group
Trot
of
equals
animals
jog,
has
Linnea.
dominated
Okay.
thinking about dinosaurs. These
And El Treehard Nub says, would it support that much weight and force? I mean, the thing is, sauropod dinosaurs were much more lightweight than you might expect them to be. Because they were all full of air. So here's a really cool figure from a recent paper by friend and colleague Carrie Woodruff, showing a sauropod dinosaur, you know, a juvenile or a subadult. This is Diplodocus or Gallimiopus or some other Morrison age sauropod. Everything that you see in blue here is air in this animal's skeleton. These animals are all full of air. They would have been a lot more lightweight than you might expect for an animal their size. So yeah. And bird-like structure, exactly, Eltria. Just like birds, they've got these air sacs and pneumatic diverticula in their vertebrae and in their torsos like this. Pretty cool stuff. Yeah. And this air came from the lungs, Hannies. Yes. Everything that you see in blue here is hooked up to the lungs. So this animal would breathe this in through the trachea. It would go into the lungs, or maybe into the air sacs before it went into the lungs. I kind of forget how avian respiratory systems work. But this animal has basically the same respiratory system as a modern bird. And it's probably the case, unless the Ornithoscelida hypothesis turns out to be true, which I think is really kind of doubtful at this point, that this dinosaur has got the same respiratory system as modern birds. Sauropods and theropods are both saurischian dinosaurs. Birds evolved from theropods. Sauropods are the closest relatives of theropods in dinosaurs. This is probably a homologous feature. It's probably that the ancestor of these guys and theropods and birds all had the same respiratory system. So sauropods, theropods, and their bird descendants all inherited this respiratory system from their common ancestor. So yeah. Yeah. Anyway. And El Trihar says that explains how they're able to survive with the quercubula, pushing them into a paste. Yeah, exactly. That's one of the reasons why sauropod dinosaurs were able to get so incredibly gargantuan. You know, like this. It's just nuts how big they were able to get. Like, as large as a jetliner. It's crazy. It's crazy how big these animals were able to get. Just absolutely enormous because so much of them was air. Yeah. Does that make sense? Pretty wild. Pretty wild. Anyway, where were we? There we are. Yeah.
Giant reptiles are Komodo dragons, lizards that can grow up to 10 feet in length and weigh 300 pounds. Dinosaur actually means terrible lizard, and the skeletons of dinosaurs are similar to these reptiles in many ways. So, like lizards, dinosaurs were thought of as sun-basking, slow-moving, cold-blooded creatures.
They were thought of. Notice the past tense there. Even in 1975, this is starting to change.
Now that basic model has been challenged. It all started with a new dinosaur being studied at Yale University by Professor John Ostrom.
Who could tell me what that dinosaur is, that new dinosaur being studied in 1975? Has anybody got any idea about that?
Tradoon.
1975. El Trija, holy cow. I am impressed. You're new here, right? And yet, you got it. Deinonychus. This critter here, I just scanned this today when I was in the library at Berkeley. This is from 1994, but really cool little conference paper that John Ostrom put together. Yeah. Very nice. Deinonychus, you are correct.
We have right over here one that...
Holy cow, look how young he is!
I think it's...
That's the femur.
This is the thigh bone, or femur. And you see it's just about the same size as mine.
A little bit smaller. You wouldn't want to meet it on a dark street, not even if you saw it as we now understand it. Because nowadays, our picture of Deinonychus no longer looks like this. Or... and there's the same illustration right there. Pretty scaly, right? Nowadays, we recognize this animal was fully coated with feathers. This is an extremely bird-like animal. Very close to the ancestor of the birds. So yeah, a feathered terror, a ground eagle as big as you. There you go, Claire Burr, yeah. And welcome back, Mayor of Space. Good to see you. Yeah. So yeah. Yeah. This, ladies and gentlemen, is the Velociraptor of Jurassic Park. It's actually Deinonychus. It should have had feathers. But, yeah. Anyway. And did all the raptors have total feather covering? As far as we can tell, Baha, yes. Dromaeosaurids, the raptor dinosaurs. Like, in fact, here's a parade of, there we go. By brilliant paleo artist Gabriel Ugueto. There's Utah Raptor. Dakota Raptor, maybe? Dromaeosaurus, Deinonychus, Microraptor, Velociraptor right over here. Yeah. They all would have had feathers like this, as far as we can tell. We've got no evidence that they didn't have feathers. All signs point to them all having feathers. Yes. And if you're looking at this and going, well, that's not very scary. And I would refer you to this webcomic right here. Actually. Yeah. There you go. Kick-Sadie, thank you for the 4 months of support. I really appreciate that. I really do. Yeah. Ah. Good stuff. Yeah. So anyway, I love that this is a web comic that has a citation right here. Fowler et al. +1, 2011. This is research done by... my old crew chief, Denver Fowler. Published on this with some colleagues in 2011. Yeah. Really, really cool paper. Check it out. Yeah. So we now think that these animals, like Deinonychus, or like any members of the Dromaeosaurid family, what members of the public often call raptor dinosaurs, they had feathered wings. They couldn't fly, except for maybe Microraptor and its relatives, its close relatives. But they were terrifying ground-running eagles, basically. Yeah. And Honigtosis, are there any raptor feathers that happen to be encased in amber? I've got colleagues working on that right now, Honigtoast. Maybe we could interview one of them sometime soon. My friend Nate Carroll was looking for some dinosaur feathers in amber. The thing is, if you find an isolated feather, it's really difficult to tell what kind of dinosaur it's from. It gets tricky. So yeah. But we do have fossil feathers on raptor dinosaurs. Raptor dinosaurs. Here we go. I'll show you this again real quick. Good stuff. There's Velociraptor itself there. If you've not seen Prehistoric Planet, you're missing out. Holy cow.
The bones of dinosaurs are often very well preserved indeed.
And Patrick Crusader says, what about raptors' tails? They were feathers? They had a, long bony tail with feathers coming off of it. So shoot. Here is a little plastic Velociraptor skeleton replica right here. There you go. There's the head. And it's got a long bony tail right here. Stiffened by ossified tendons. Like we see in Deinonychus also. So, yeah. Anyway, you'll see here.
But that's not the case with the skin or the soft parts. So imagining what they looked like has been largely a matter of guesswork. But now some truly exceptional fossils have been discovered that have changed all that.
Yep.
One of the most startling discoveries has been the presence of feathers on a large number of species, including Velociraptor.
Mm-hmm. So that's what a velociraptor tail would look like.
Velociraptor were fully feathered is no longer at all controversial.
We know this for a fact now.
Of about 60 dinosaur species that are completely covered in feathers, just like modern birds.
Oh, and by the way, shoot. You see that silhouette right there? And this silhouette right here? Do you recognize those? This one, and this one right here? Well, well, well. Take a look. There's Microraptor, there's Deinonychus, there's Utahraptor. They used Gabriel Ugueto's art in this. Right there, right there, right there. Very nice.
Some of the perfect fossilized feathers have been discovered in China.
I think he did get paid. I hope so, Sagiguana, yeah.
Found in 2015. It's called Zhenjualong.
Yeah.
And you can probably guess from these huge claws on its feet that it was related to a velociraptor. But also, you can see amazingly perfect detail of feathers down its tail and more.
He's in the credits. Oh, cool, Zucchini Puff. That's good to hear. Yeah.
For Velociraptor in particular, fossils have even been found with indentations in the bone.
Yep.
Showing exactly where feathers would have been positioned.
Good stuff. So we know that these animals had feathers. Yeah. There we go. So this animal looks very much incomplete when you realize that this is really what it should look like today. It just looks super naked. It looks like if you took a tiger and just shaved it. So it's just bare skin. It just looks wrong. Like, completely wrong. Yeah. And Honig Toast, not a stupid question at all. No, great question. Did Tyrannosaurus also have feathers? We're not totally sure yet. I suspect they would have had feathers when they were young, and maybe they lost them later in ontogeny as they grow and mature, get bigger. Because a full-grown Tyrannosaurus, holy cow, it would have... Oh boy. Their problem would be dumping heat. Rather than, you know, maintaining body temperature. But there are some depictions of Tyrannosaurus that show them with feathers like this. I really like these just from like a science outreach standpoint. There's Bob Bacher right there, somebody who looks like Bob Bacher right there, about to get stomped and crunched. But yeah, this is from the game Saurian, by the way. Excellent game. You should check it out if you like dinosaur games. It is my favorite dinosaur video game. One of the few dinosaur video games I've ever played on stream. Although they're moving to this model for Tyrannosaurus because after they built the previous model, there was a paper that came out that showed some skin impressions from Tyrannosaurus that didn't have any sign of feathers, but they're from very patchy places on the body. So anyway, I suspect that the animal, as it's growing and maturing, it may have had feathers early on and then later lost them as it grew and developed. Because when you're small, you need, you know, as any physicist can tell you, the larger the object, the easier it is for it to maintain its temperature. The smaller the object, the greater the surface area is compared to the volume, and it loses heat more readily. So the smaller you are, kind of the more attention you've got to pay, the more effort you've got to put into maintaining your temperature, you know? So yeah. Yeah. Reaching for 6 shooters. There you go, Mayor's face, yeah. Although you'll see a young Bacher here. Yeah, the inverse square lot. There you go, Wombat Hole. Yeah. Yeah.
At night, I'll tell you. This was another surprise in Deinonychus.
God, John Ostrom
Here we
so
have
young.
a series of tail vertebrae running from the tip of the tail up to the base of the tail, a total length of maybe about 4 feet.
There's also
The unusual
Deinonychus.
thing about this series,
Look at those ossified tendons.
Tendons along the tail that
Yeah.
normally are soft tissue have turned to bone, and they're
Yep.
ossified. And as far as I know, this is the first time that this particular kind of structure has ever turned up in a carnivorous dinosaur.
Pretty cool.
When we first saw it, I really didn't know what to think. But then, remember the terrible claw? You think about that foot with that big sickle-like claw that he must have used as a weapon. Remember, he's a two-legged animal, can't walk on all fours. He's got to walk on his hind legs. How is he going to use that claw if he's standing on 2 feet? Impossible. He's got to jump around, leap around, using that claw to strike out at whatever prey or animal he's after. This means that he must have been extremely agile, very quick, good balance control, means a high neurological development. And this tail, that reinforces that picture, because here we have essentially a balancing pole. They're like a tightrope walker.
Very, very nice. I'll be excited to show you this on tomorrow's stream when it is completed, hopefully. But for right now, it's time to wrap things up. There's the skull of Deinonychus, this dinosaur that Ostrom was talking about right there. And we'll run our credits over it. I've got, a bunch of stuff I got to take care of tonight. So, I'm going to get to that. But don't go away just yet. Everyone, we are going to see if we can raid into somebody else doing some science right now. And there's Science Streams. Playing something called Pickman 4. Well, well, well. He's starting in less than 4 minutes now. Wow, you could be there from the very beginning of the stream, everybody. And maybe ask Science Streams about gene expression and its role in evolution, like we were talking about earlier. Anyway, thank you everybody who's showing up here in the credits. Thank you for all of your support. Thank you for everything. From those hardworking moderators to the first-time followers, to the gifters and the cheerers and the subscribers and the lurkers too. Thank you very much for helping me do what I do here on Paleontologizing. It would not be possible without your help. So thank you. And Scuba Do It, thank you for the follow. Welcome to Paleontologizing. Sneaking that one in just under the wire. And hang on a minute. Did our rate thing? Oh, I didn't hit enter. I guess it didn't work with the @ symbol. We're gonna go check out Science Streams. You're in for a treat if you've never seen Science before. Molecular biology, systems biology, ants, genetics, science outreach, games? Something called Pikmin 4. I don't know what that is, but if they've made 4 of them, then they're probably fairly successful. Let's go see what Science is up to. I'll see you there, everybody. You take care. And I'll see you tomorrow for another stream. All right, till then, bye-bye. See you in Science Streams.